Hello, my dear NEET warriors. Welcome to the next session of your Roar NEET Aspirants series on YouTube. And yes, that's your RNA series. And today we are going to do motion in 1D, a very, very important topic. And yes, 11th standard topic, and one of the first few chapters of your 11th standard physics syllabus. Complete in detail class. Although this is a marathon, some of you might be wondering, is Sir going to teach in detail? Well, you will see that it's going to be in detail, and not just apart from the theory, we are going to also apply theory concepts into problems with PYQs and NCRT questions as well. So if you are scared of 1D motion questions, this is the lecture that you should see till the end. With me, your captain Shreyas, your physics master teacher, training kids since so many years. And here you are. And the chat box is on fire, truly. And it's really amazing to see this particular chat box on fire. Really good, guys. Thank you so much, Krishna, Sushmita, Satyashri, Papita. Hello, Nana. Hello, Pratibha. Hello, Asim. Hello. Good evening, my dear warriors. It's really, amazing to see all of you over here. And we have daily classes. We have amazing content in detail classes in this RNA series. Let's go. Yes. Thank you, Lakshmi. Oh, by the way, let me tell you, this particular NEET PDF will be available only for the next few days because we have to pay on the server to load all these things. So understand that. So this will go off within few days. If you have not yet downloaded these material, please download it. It's not just the syllabus, but you have revision book, mind maps, also important PYQs, most repeated questions, questions where everybody goes wrong, and also all the question papers are there, and also list of the medical colleges. So I think you should definitely download it as well as the mock test. Please try to complete it as soon as possible because this won't be available only after a few days. Okay, so that's your NEET PDF. Link is there in the pinned comments as well as in the description box. Cool. So let's begin with the class, and everybody is super duper excited. Thank you for liking. If you have not yet liked, please like it right now. And some JEE aspirants are also here. Okay, guys, by the way, let me tell you, we also have a Vedantu JEE English channel where I'm only teaching. So you can watch over there too. Okay. And by the way, I also wanted to know how many of you are from Karnataka? How many of you are from Karnataka? And do you want Shreyas sir to do something for the students of Karnataka? ನಮ್ಗೆ ಕನ್ನಡ ಗೊತ್ತು, ನಮ್ಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತು. Okay, so if you want something, well, we will plan for it. Because we already have something in Telugu, we already have something in Tamil, we have in Hindi, of course. English, we created the revolution. What about Karnataka students? We want all the students to be benefited. Let's see what we can do in the days to come. Now, let's talk about motion and kinematics. Well, motion is a very random word, which you can say, but a sophisticated way of saying it is kinematics, where you study how the motion occurs. So kinematics is basically the study. It's basically the study of whom? The motion. How it is happening. Where are you? How much time will you take? Etc. etc. You're studying how the motion is happening, where it is, how, when are you, etc. Now, see, this concept of motion is also very relative. Like, for example, yes, it is relative to the observer. For example, imagine there is this beautiful champa who is walking, and we have a pandu over here. We have a pandu over here who is at rest, who is basically not moving. He's just, just standing against the wall, and he's looking at this beautiful champa who is moving. So for this particular pandu, this particular champa is in motion. For this particular pandu, this champa is in motion. But just imagine now what happens in the next scenario. For that same champa which is there, for that same champa which is there who is moving, imagine Pandu starts walking with her, he's following her behind her, he's following like this, he's running behind her. In such a case, because Pandu is running with Champa, Pandu will find Champa to be at rest. Pandu will find Champa to be at rest. So, in this case, understand our Pandu was nothing but our observer. Was nothing but our observer. So, whether something is moving, not moving, how fast is moving, depends completely on the observer as well. Do you guys agree with this? Yep. Bharineshwaran, this will be, I think, for some time. I mean, like around 4 5 hours. You can guess. Yeah, around 8 o'clock maybe. Yeah, that's what you can expect. Great. Now that you understand, okay, motion is relative. It depends on the observer. What do you call this observer in physics terms? Do you know what is the name? The name of this observer? You'll be like, sir, he's called Pandu, sir. Yes, he's Pandu, but is also called as the frame of reference. Frame of reference. Frame of reference. Also, point of view. According to Pandu's point of view, according to my point of view, according to Champa's point of view, according to their perspective. That is what it means. Point of view, frame of reference. So, according to our point of view, so let's say there is some x-axis, there is some y-axis, there is some z-axis, this is the origin, and our cute little Pandu is sitting over here making all the observations. Okay, our cute little Pandu is over there and he's chilling out, just like probably how Shreyas Sir chills out in the thumbnail photos. You know how, just like this, just like this. Okay, Pandu is just chilling out, waiting when will Champa pass. Okay, and then comes Champa, and Champa is over here. Champa, oops, let me do a beautiful Champa, not just any Champa. Okay, beautiful Champa over here. So Champa is over here. So if I draw a line, it is not that line. I know Pandu is giving line to Champa, that is different line. If Pandu looks at Champa, okay, Pandu looks at Champa. So this is called as the position vector. If you remember, this is called as the position vector. It points to where that observed quantity is. It points to where that particular observed quantity is. Exactly. So, in case of motion in 1D, in case of motion in 1D, our observed quantity, not a very nice way of saying it, but our Champa is going along a straight line. She is not going like this. If Champa goes like this, then it is motion in 2D. If Champa gets wings and she starts flying and she's going here and there, then that is motion in 3 dimension. But our Champa is going pavam. She is going in one straight line. She just goes from home to college. Straight road, she goes like this. After college, she comes back like this. Straight road. She just goes motion in 1D. Why? Because our chapter name is motion in 1D. So Champa has no way else to go. She just goes in one straight line. Exactly. So in such a case, so this was, let's say, in motion in 3 dimension, where Champa might be moving something like this. Champa could be moving like this anywhere. In case of one-dimensional motion, what I will do is, I just take care only of one direction or one axis, let's say x-axis or y-axis, and I'll just mark an origin, and our Champa will be going only on that line, either y-axis or z-axis or x-axis. She can go either right, left, up, down, whatever. Okay, so that is basically our motion in 1D. That is basically our motion in one dimension. X-axis is one dimension, y-axis is the next dimension, z-axis is your third dimension. So she is going exactly in one dimension. Is that right? And then wherever she is located right now, let's say I call that coordinate as x. So this x coordinate is basically called as the position along that straight line. Position along that particular line. Position along that line. Okay, so it is basically the position along that line. Many times this position is often given sometimes I would say, sometimes this position is given either directly, it is given directly, or sometimes it is given graphically, or sometimes it is also given as a function. It is sometimes also given as a function of time. What do I mean by this? What do I mean by it is directly given, it is given graphically, or it is given as a function of time? Imagine I tell you our Champa is 5 meters to the north of Pandu. It is basically now directly given. It is basically now directly given. If our Pandu is over here, if our cute little Pandu is over here, where is Champa? North. North is somewhere on the top over here. So Champa is basically over here, and this distance is nothing but how much? This is 5 meters. This is what it means when it is directly given. What does this mean? It is basically directly given. This is your first scenario. What about second scenario? It is given graphically. What does it mean? It is given graphically. And see, indirectly, then you have to mention, now she is here, after some time she is here, after some time she is here. So that is basically in statements or in words. But let's say, for example, you are giving it graphically, something like this. This is the second way. So imagine there is a graph given like this. There is a graph given like this. This is time and this is x. And the graph given is something, let's say, like this for Champa. It is like this and like this and maybe like this. So from this you will understand, okay, when my clock started, when I started observing, that time Champa already was on some positive coordinate. Maybe I can just call these numbers. Let's say this is maybe +2. Let's say this is +5. Let's say this is at maybe 2 seconds. Let's say this is at 6 seconds. Let's say this is at 8 seconds. And let's say this is -3. I'm just taking some random numbers just to make you understand what exactly might be happening. So on the number line, if I draw my number line, this is our x-axis, this is our 0. Then when time is 0, that means initially, where is Champa? At x is equal to 2. At x equals to 2. X equals to 2 is somewhere here. This is where Champa is initially. This is where Champa is basically initially. That's what it tells me graphically. Then after 2 seconds, where is she? At x equals to 5 meters. At x equals to 5 meters. So x equals to 5, maybe somewhere over here. Maybe somewhere over here. This is basically 5 meters maybe. This is maybe 5 meters maybe. So where is she? After 2 seconds. This is basically 2 seconds. After some more time, after 6 seconds, she is at 0 coordinate. She is at 0 coordinate. That means over here at t is equal to 6. At t is equal to 6. So she went here, she has gone here, she turned, and she has come back over here. That is what it means. And at 8 seconds, it's a basically -3 coordinate. It is basically a -3 coordinate, -3 meters. So that means at 8 seconds, at t is equal to 8 seconds, she is over here. That means Champa has come till this point over here. This is how you will visualize it. So Champa started from here, she went ahead and she came back to the origin and even went behind the origin on the negative side. That is what it explains to me graphically. Are you able to visualize this? Just try to visualize this. 0 seconds, Champa is 2 meters from the origin. Then she moved to 5 meters from the origin. Then after that, the graph came down. So Champa came back to the origin at 6 seconds. And at 8 seconds, she went to the negative side. That is what Champa has done. She has gone here, she has turned, and then she went over here. That is how you visualize it graphically. The third way is as a function. The third way is basically as a function. Example, if I tell you x is equal to 3 plus t square, where you tell me the time, I'll tell you where You tell me the time, I'll tell you where Champa is. So let's say time is 0, then time is, let's say, 1 second, then time is, let's say, 2 seconds, then 3 seconds. Example. So I can tell you where Champa is. At 0, time has 0, 0 square is 0, 0 plus 3 is 3. So x is basically 3. Time is 1, 1 square is 1, 1 plus 3 is basically 4. Time is 2, 2 square is 4, 4 plus 3 is 7. 3, 3 square is 9, 9 plus 3 is basically 12. So that means if I think of the number line over here and this being the origin, so at 0 seconds you are already at 3 meters. You are at 0 seconds, you are already at 3 meters. This is at t is equal to 0. 0 means initially time. Initially, when you just started it. And then slowly you are moving away. T is equal to 1, you are at 4. T is equal to 1, you are at 4. Then t is equal to 2, you are at basically 7. T is equal to 3, you are at basically 12, and so on and so forth. So you have started moving really fast over here. So you are at 4 meters, then you are at 7 meters, then you are probably at 12 meters. So this is how Champa is moving. She has started from here and she slowly started to move towards this side. This is how you will visualize it. Is that clear, everyone? Understood, everyone, till this point? What is position, truly speaking? Everybody understood what is the meaning of position? I hope I have explained it in detail. So position is basically nothing but a coordinate. It can be given to you directly like this one, in words, in statements. Second, it can be given to you in graph form. Also, it can be also given to you in a function form like this, some function. Now let's talk about distance and displacement. Let's talk about distance and displacement. Every day you might have gone to school or your college and came back to your house. Hopefully, everybody started from your house, went to school, and again came back. But while coming back, usually you'd never have that mood to come back to your house. So suddenly you go to your friend's house, then you went to chill out, you went to eat pani puri, then you felt like eating some dosa, then you felt like playing cricket, then you felt like, okay, again let's go to our friend's house. Okay, now we are bored, mommy is calling, so let us go back to our house. So you went back like this. So at the end of the day, what is your displacement? Displacement is how much have you literally displaced from your original position. My original position was here. I moved, I did all the nonsense. Then I came back home, got beatings. I got flying slippers. That's the second story. But I came back to my original home. I didn't go to anybody else's house. That would be bad. So my displacement is 0. Exactly. My displacement is 0. But is my distance, which is the path length which I have traveled, is it 0? The answer is no. Distance is the length of the path. Displacement is from the initial to the final, how much I have literally moved. You just see the separation. That is displacement. So my distance is there, but displacement is 0. So that is the difference between distance and displacement. Okay. In fact, I have put it in words, hopefully. On the next slide, yes. So distance is the total length of the path covered in some interval. Usually the symbol for distance is small d or basically capital D, and it is, remember, a scalar quantity. It is basically a scalar quantity. Displacement, usually you use the symbol S bar, okay, and this is nothing but a vector quantity. It is nothing but a vector quantity. Not just that, both of them have the same units. Both of them have the same units, either in meters or in CGS, it is centimeters. If you talk about the dimensions, it is length raised to 1. That is the dimensional formula for distance or displacement. One more interesting thing that you see is, let's say for example, you started from here and went along a straight line and you ended over here. In this case, your displacement is equal to the distance traveled. Your displacement and the distance is the same. But let's say some other day, what happened is you moved like this, you forgot something. Oh, but then you realize, no, I have taken it, and you again reached over here. Or let's say you started here, you went here, you went here, you got bored, you went there, and then you came back. This is how the route looks like from the toilet to your class. right? This is the leaked footage of your path from the toilet to the class, washroom break. But from the class to the washroom, this is the path. This is the leaked footage of the path taken from the classroom to the toilet. Toilet to the classroom, this is like this. Aram se you will meet some people, you will go here and there, staff room, library, blah, 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 and you will reach here. So, in this scenario, my dear warriors, do you see? Probably the displacement is the same, but the distance is more. So hence the displacement is lesser than the distance traveled. Displacement is lesser than the distance traveled. So in general, can I say, in general, in general, can I say displacement is lesser than or worst case equal to the distance traveled. Displacement is less than or equal to the distance which has been traveled. Yep. Very good. Correcto. Awesome. Awesome. Now, another important thing about distance and displacement, let me show you to you over here. Let's say this is distance on one side, and on the other side, we have displacement. Okay. And I'm asking you, which of the following are possible? My distance traveled is 0. Displacement is also 0. Distance traveled is 0, but displacement is not 0. Displacement is 0, distance is not 0, and both are non-zero. Which of the following are possible? Which of the following are possible? Okay. This distance and displacement both are 0. I think it is possible. Have you seen a donkey? You might have got scoldings also from your parents someday or the other. You are sleeping like a donkey. So this is our donkey. What does a donkey do? Does it go some? No. Does it have a job? No. Does it have purpose in life? Nothing, not much. Very simple it is. Very simple animal. No NEET 24, no scam, no cheating, no NEET 25, no taking drop. Just stay there. A donkey can just stay there at the same place. So distance and displacement both are 0. This is possible. So this is basically donkey at rest. This is basically donkey at rest. Definitely it is possible. Exactly. What about this? I think this is also possible. This is like when you have to run somewhere, you have to go somewhere. Basically, I remember our Champa, beautiful Champa, she was going to the college every day, Papa. She was going like this. Okay. So, yes, this is possible in motion. What about these two? Distance is not there, but displacement is 0. I think this is also possible, guys. I mean, just think about it. You went here and you came back. You went here and you came back. You came back to the same point. Initial and final location are same. Initial and final location are same. Then this is possible. You have traveled something, but displacement is 0. Yep. Very good. Most of you have got the answer. Most of you have got the answer. Yeah. Okay. It's not like a donkey. It's like a pig, is it? I don't know. But the legs are very tall. Is it a tall pig or something? I don't know. It's a new species. You should ask Gopika ma'am because she teaches you zoology, right? So please ask Gopika ma'am which animal this is. If she answers properly, that means she is an expert in zoology. Okay, correct. All right. What about this? What about this? 0 and not 0. 0 and not 0. This is not possible only, guys. This is not possible only. Yeah, this is not possible because how can you not travel and have some displacement? It's like saying you have traveled 0 kilometers, but your initial and final location are not the same. Are not traveled, but magically have moved somewhere. How is that possible? This is not at all possible. Correct. Perfect. Okay. Now, displacement in terms of vector form, I'll just tell you that as well before we go ahead. So this is in 3 dimension. Let's not worry about 3 dimension for now. Let's just worry about 1 dimension. So if this is our x-axis, something like this is our origin. Initially, Champa was over here. Initially, Champa was here at t is equal to 0. And after some time, Champa is over here. This is at t is equal to t. Sometimes people also like to write it like this. This is at time t at some instant. This is at time t plus delta t. So this is after delta t time. This is basically an interval. This is basically an interval. This is an interval of time. Champa has moved this much. So obviously the displacement of Champa would be this much. This is the displacement. It's a vector. It always starts from original or initial to the current or the final location. Always. Okay. So what I can say is, if Champa had some coordinate xf over here, or let's say x2 over here, whatever, xf, and this is, let's say, xi coordinate, then our displacement which is there, will be nothing but the final coordinate minus the initial coordinate. That's all. So that is the displacement formula. But usually you will not write it like this. Rather, you will write it as delta x. Delta means final minus initial. So usually you will write it as S is equal to delta x. S is equal to delta x, which is change in the position. So this is the best way of writing this. Displacement is equal to, delta means change. What is x? Position. Change in position. Displacement is change in position. So that's the way you define this. I hope this much part is very, very clear. Everybody with me? Awesomeness. Cool. So if Shreyas Sir tells you x is, remember sometime back I gave you some equation, 3 plus t square, find the displacement from t is equal to 1 to t is equal to 3 seconds. Imagine this sort of a question came. Okay, this is like a pure conceptual question. Find the displacement from t is equal to 1 to t is equal to the 3 second. What will you do? Okay, I will first put t is equal to 1 and see what is x. So when I put t is equal to 1, it will be 3 plus 1 square, which is nothing but 4 meters. Then I will put t is equal to 3. So it will be 3 plus 3 square, which is 9 plus 3, which is 12. What is the displacement formula? Delta x. That means final minus initial. So hence it is nothing but 8 meters. So therefore the displacement is nothing but 8 meters. Displacement is nothing but 8 meters. We got it. Understood how to find this out if the equation or anything is given? Let's do more questions coming up on your screen. An athlete is completing one round of circular track of radius r in 40 seconds. What will be his displacement at the end of 2 minutes 20 seconds? Yes, correct, Jaivi. Very good, Pavitra. Very good, Madhumati. Awesome, Krishna, Pratibha, Sushmita, Gopinath. Awesome, Divya. All right, let's see, Satyashri. Next question. Okay, this athlete, he is going what? One round in a circular track of radius r in 40 seconds. 40 seconds he takes. 40 seconds he takes to complete a track of radius r. Okay, what will be his displacement after 2 minutes 20 seconds? What is 2 minutes 20 seconds first of all? 2 minutes 20 seconds means 120 plus 2 minutes is 120 seconds plus 20 seconds, which is nothing but 140 seconds. Interesting. So think about this, guys. 140 seconds, I can split it up into 40 seconds plus 40 seconds plus 40 seconds plus 20 seconds. This plus this plus this, all of them together will make it 140. Why did I do that? Because in 140 seconds, or one round is completed in 40 seconds, another round is completed in the next 40 seconds, another round is completed in the next 40 seconds, and in 20 seconds, where will he go? He will just reach here. From this side, he will just go here. So basically, these things are nothing but 3 complete rounds. 3 complete rounds. What is this? This is just half a round. This is nothing but half a round, my dear warriors. So essentially what he has done, 3 complete rounds like this, and then gone to the other side. So this is final, this is initial. The question is, how much is the displacement? Displacement is this much. This is the displacement. Displacement is the diameter of the circle. That means it is 2 times the radius. What will be the displacement. It will be 2 times the radius. What is the radius? It is given to be 2 meters, is it? It is given to be r. So it will be 2 times of r. I don't know. Somehow they put the radius as 2 meters. So 2 into 2 is 4, which is also correct. Yes, perfect. Very good, very good, very good, Neha, Pratibha, Artaluru, Satyashri, awesome, Gopinath, Jevi, Sherlin. Very good, very good. Excellent, Sherlin. Awesome, Krishna. Let's move to the next one. The numerical ratio of the displacement to distance for a moving object is interesting. The numerical ratio, meaning the magnitude, the value, if you take numeric means value. If you take the value of the displacement and divide it with distance, if you take the value of the displacement and divide it with distance, what do you think is this going to be? Wait a minute. I know displacement is always less than or equal to d. That means numerator is less than denominator, y is equal to. So hence, can I just say this is, just take d below, guys. It is just less than or equal to 1. It is just less than or equal to 1. That's all. So it is equal to or less than 1, which is a. Amazing. A for Attaluru. What is Attaluru is our student name. Nice. What a nice name. Attaluru, are you from Andhra? Andhra ka unnaru? A for awesome Gopika also? Yes, awesome Gopika ma'am, correct. A for aims also. Very good, Krishna. All right, moving on to the next question coming up on your screen. But before that, we'll talk about speed and velocity. So whenever Champa says to Pandu that I need to move away from you, I need some space and I need some distance and I need some time, that means Champa is asking for her velocity. Understand that. So anytime any girl or any boy is saying, I need some distance from you, I need some time from you, what they actually mean is I am calculating velocity or I need to find out what the velocity is. So you can ask them how much distance, you can ask them how much time and divide the two numbers and what you get is the velocity. Keep that in mind. Okay. So speed and velocity, actually it's very simple, guys. If you are just talking about speed, it is just nothing but distance. It is just nothing but the distance which you have traveled upon the time which you have taken. Whereas if you are talking about velocity, whereas when you are talking about the term velocity, it is nothing but how much is your displacement which you have undergone upon the time taken. Yes, exactly. Now, speed, just like distance, is obviously a scalar quantity. It's a scalar quantity. There is no direction associated with it. Okay, but for velocity, you always need to tell which direction. Okay, which direction. So always remember, if your girlfriend or boyfriend ever asks you, I need some distance, then you are calculating speed. If they ask that I need some displacement in my life, I need some time, then they are asking for velocity. Then when they tell you that I want some displacement, you should ask, which direction do you want to displace Champa? Which direction do you want to displace Pandu? Because you will, then when they ask you, why are you asking which direction? Then you should tell, listen, displacement, vector quantity. Okay, so that's how you will remind them. So this is nothing but your vector quantity, correct? Whereas both of them have the same unit only. There is no difference in that. Either you use meter per second or you can use centimeter per second. And dimensions wise, this is meters per second. So L raised to 1, T raised to minus 1. Just like before, you will see, since distance was always more than displacement or worst case equal to, that's why your speed, will be more than or equal to the velocity. Okay, will be more than or equal to the velocity. So this also holds true even over here. This also holds true even over here. Keep this in mind. Very good, very good, excellent. Awesome. Now, what is the formula-wise look? Formula-wise look will be something like this. It will be distance divided by the time. Let's say the time taken is delta t. Here, the formula for whatever I have written over here is actually for average, by the way. So I'll just put it on the next slide. So our average velocity, also I can symbolize it with triangular brackets, is displacement. Displacement is S divided by delta t. If you don't like S, you can also put delta x, one and the same thing. Okay, S or delta x, one and the same thing, guys. So this is our formula for our average velocity. Average velocity. This triangle bracket means average. Please keep that in mind. Okay, so if I say average F, it means average force, which is the same as writing F subscript average. I don't like this. I usually like this. Looks cool. So if you put marks, if I put marks and I put this symbol, it means I'm talking about average marks. So that is the symbolic way of writing average in triangular brackets. Now, what do I, or how do I distinguish between average versus instant at that moment? This is average, meaning imagine this particular person was moving like this here. So this is a long distance, but you can just draw one straight line. That is the displacement. That is the displacement, which is S. You divide that with the time taken. You divide that with the time taken. You will get the average velocity. You will get the average velocity in the same direction as that of the displacement. Fair enough. This is average. But maybe while going from here to here, my motion was not continuous. Maybe it was jerky motion. Once I was running, then I took a break. Then I got bored. I looked behind. I started running behind. And then I got bored. Then I went here. And then I started running here. So this is on an average as a whole. But at every single moment, I was maybe moving very fast, maybe at rest, maybe moving on other direction, maybe moving slow. It was continuously changing. So that is at that moment is called instantaneous velocity. That is called instantaneous velocity. Tell me one simple thing. Everybody has ridden a scooty at least, or seen your dad or mom ride some bike, or seen them driving a car. And you would have seen this in your car's instrument cluster. A nice dial will be there like this, right? And there is a pointer over here, 0, 10, 20, like that, maybe 60, maybe 100, like this. And you would have also seen on the side there is a number which keeps on changing. A number which keeps on changing. Maybe it shows right now 2566.7, something like this. You might have seen this. What is this and what is this? What does this show? What does this show? Come on, guys, think about it and tell me. Think about it and tell me. So this one over here, this is called as the odometer. This is called as your odometer. And what does this show? It shows you the distance which you have traveled since the time you bought your car. Since the time you bought your car. And what is this? This is your speedometer. Speedometer. And what does it show you? Average or instantaneous? It shows you instantaneous speed. At that moment, what is your speed? And it keeps changing. It is not showing average. It is not showing average. You also have your watch with you. You also have your watch with you, right? You also have your watch with you. You also have your watch with you. And this basically watch, what does it show you? It basically shows you time. And using the data from the odometer and from the time together, what you can find is the average speed which you have traveled. You can find the average, because this is total distance, this is total time. So if you give me total distance and time, I can find the average speed. But the instantaneous is calculated by the speedometer. Is this differentiation clear? Exactly. Everyone understood this? Everybody understood this? How these calculations go? Very nice. Awesome. So now going on to instantaneous. What is the representation of instantaneous velocity? So instantaneous velocity V. You don't put any symbol. No average, no triangle, no circle, nothing. Just put that symbol. That is instantaneous. If I just put F, force at that moment. If I just put P, momentum at the moment. If I put some A, acceleration at the moment. There is no average then. That is then written down as instead of delta x by delta t, instead of delta x by delta t, dx and dt. So what we can also do is we can cancel this d and d and it will become x by time. Correct? You don't do that because guys, how can you do such things? That is nonsense. You can't do that. Then you should cancel this delta and delta also. No, that is not delta into x. It is delta of x, change of x. So this is d of x. This is d of time. What does this actually mean? This basically says a very, very small time. Very, very small time. That is basically delta t is becoming very close to 0, but delta t is not 0. This is what it means. Dt is very, 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 very small, but it is not 0. That is what it means. Excellent. And this dx is that very, very, very small chintu mintu. You can call it chintu mintu. This is very, very chintu mintu. This is chintu mintu. This is your chintu mintu displacement. Chotu, chintu mintu displacement. You give me 0.0000001 second, and at 0.00001 second, I would have moved 0.00023 meters. So that very small chintu mintu displacement. If you divide that, I'll get the velocity at that moment. Don't think instantaneous velocity will be very small, guys, because think about it, 0.0000005 upon 0.00001 is not very small. Obviously, all these decimals will go away and you'll get the answer as 5. So don't expect instantaneous velocity to be small. It's a small number by small number, so it will be a good number only. Okay, that's again a wrong notion which many people have. So it is the dx by your dt. So that is what I have put over here. Average is total by total time. Instantaneous is dx by dt. Excellent. Is the derivative. Excellent. Awesome. 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 Moving now to some questions. Wow, what do we have? Read this question, guys. A car is going on a straight road. It covers 1/3 distance with 20 and the rest with 60. Average speed you have been asked. Let's imagine this. Always imagine. Draw. Like, sir, I can't imagine. Draw. You can draw? Yes, very good. So draw. So car is moving straight road. 1/3 in some speed, rest with some another speed. 1/3, let's say I call it x. How much will be remaining? 2/3 of it, which is basically 2x. So this will be 2x. This is how I look at it. From here to here is x. From here to here is 2x. X, 2x and x. 1/3, 2/3. Everybody is able to visualize this much part? Awesome. 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 Very good. Oh, Gopika ma'am is here. Oh, that is, I think Gopika ma'am is Mintu and Chintu was Diksha ma'am. Yes. So now, once you have understood, okay, 1/3 is, assume some x. There is no harm. Like, sir, x is not given. Obviously, it is not given. Assume it. Later on, it might just get cancelled out. And from here to here, it is the remaining. Remaining is 2x. Okay. Great. 1/3 and 2/3. All right. From that, for that initial part, you are moving with a speed of 20 kilometers per hour. And for that remaining part, you are moving with 60 kilometers per hour. Question is, for the entire duration, what's your average speed? What is the definition of average? Come on, guys. Average speed. Total distance and total time. Oh, total distance x plus 2x. Wow, so nice. Total time from here to here and here to here, here to here and here to here. Is there a formula for time which I know? Time is distance by speed, because speed is distance by time. Time is distance by speed. So time from here to here is distance by speed. Speed is 20. From here to here, the time is t2. So that will be that distance by that speed, which is 60. Do you guys agree with it? So it will be basically T1 plus T2. It will be basically total time T1 plus T2. So let's do the math now and see what do we get. X plus 2x is basically 3x, the whole thing divided by what is T1? T1 is basically x by 20. T2 is basically 2x divided by 60. 2 goes with 60, this will become 30. X will get cancelled. X will get cancelled. Awesome. So what are we getting over here is equal to 3. And what is remaining? 1 by 20 plus 1 by 30. Everybody with me? 1 by 20 plus 1 by 30. 2 and 60 cancelled. It remained as 1 by 30. Perfect. Take the LCM, of course. Take the LCM, of course. So it will be 3 divided by LCM of 20 and 30 is 60. So this will be 3 times. This will be 2 times. Perfect. 3 plus 2 is 5. So it will be 3 by 5. And that 60 goes on the top. So 60 over here. 5 goes with 60. 12 times. 12 3 is 36. So answer is 36, which is D. D for Diksha ma'am. Oh yes, perfect. It is the correct answer. Got it, everyone? Everybody got it? Perfect. Awesomeness. So this is how you start. You're like, sir, the X was there, it got cancelled. You just saw this step. X got cancelled. So don't be afraid of assuming certain variables. I know some of you are scared of this. Sir, why this X came in my life? Sir, why this X came in my life, sir? I'm not talking about your ex-boyfriend or girlfriend. I'm talking about this variable X. Yeah. See, that ex-girlfriend and ex-boyfriend is very scary, but this X got cut, a numerator and denominator. So this is what happens in maths versus real life. In that real life, that X comes means full problem. In mathematical and physics life, when X comes, no, full cancelled out. Very nice it is. So that's why you should love maths and physics. Okay. Moving on to the next question coming up on your screen, and here it is. The train has a speed of 60 for the first 1 hour and 40 for the next half hour. Find the average speed kilometers per hour. Okay, let's find it out. What is it? First half an hour. Okay, half an hour. You are going with how much speed? Less speed. 40. Tuck, 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 tuck. Half an hour you are going. Half an hour. And then stop. What is it? Next half an hour? More speed. So you will travel more distance, of course, in that next half hour. So here this was 40 kilometers per hour. Here 60 kilometers per hour. Question is find the average speed again. Oh, I don't know the distances only. Let's assume this as x1. Let's assume this as x2. Sir, why x1 and x2, sir? Why not x and x? Think logically. Two x's we got now. Oh my god, this is like scary, guys. I mean, imagine having two x's in life. Oops, full masala only. Okay, so from here to here it is x1 and here to here it is x2 because your speeds are different, right? So if you're traveling with different speeds, you will move also differently. So that's why different x. Perfect. So let's try to find out what is the average speed now. Well, let's try to find out what is the average speed. Total distance, which is x1 plus x2, whole thing divided by time, which is t1 plus t2. Okay, what is x1 and what is x2, sir? X1, distance is speed into time, sir. So it is 40 into half. Okay, x2, distance is speed into time. Time is half. So this is basically 30. This is basically 20. So x1 I'll put it as 20 and x2 I'll put it as 30. And the remaining time t1 is half plus this is also half. 20 plus 30 is 50. Half plus half is 1. So the answer is 50. Where is 50? Option A for AIMS. Oh, yo, what did they put? They put it as wrong. This is not the correct answer. This is the correct answer. Okay. So time was given. So answer is 50, guys. Yes. I hope this is clear. Everyone? Awesome. Done? Dusted? Shall we go ahead to the next question? Okay, let's go to the next question now. This time full variables. No values. All V1, V2, V3 like that. Okay. So we'll try to solve the question in terms of variables only. A car 2/5 of the distance with V1, 3/5 of the distance with V2. Average speed is asked. 2/5. How you visualize 2/5? You take something, divide it into 5 parts. And out of those 5 parts, you take 2 parts. The remaining parts will be 3 parts. So you take something, divide it equally into 5. You take 2 parts out of it. That means 2x. You can call it. Again, x comes, guys. And then the remaining parts will be how much? 3x. This is how you can visualize it. And this much part you're traveling with V1, this much part you're traveling with V2. Times are obviously different. So this is T1, this is T2, distance is different, speed is different. Obviously, times will be first 1 hour, is it? What was it? Ayo, it was not it was not half an hour, it was 1 hour. My bad. So we'll change the question, guys. It will be better. First, I did not read that one. So sorry. I'll just change the question. We'll call it half an hour. So then it will be perfect. If it is 1 hour, then this will be 1 plus half, which will be 3 by 2. So 3 by 2, 2 goes over there, 100 by 3. That's what it will be. Okay. So that was a different thing. All right. And here also, sorry, this 20 will also become different because then it will be 40 into 1. So it will be 40 plus 30 whole thing divided by 3 by 2. All right. So it will change accordingly then. So I just solve the question now for half an hour. I just change the question, but you can put any values, you will get accordingly. Anyways, now coming back over here, T, what is this time? What is this time? Total distance by speed. This time distance is 2x divided by speed. What is this time? This distance divided by this speed. So now let's try to find out the average speed, which is total distance, which is 2x plus 3x, whole thing divided by T1 plus T2. What is 2x plus 3x? It is basically 5 times of x. What is T1? T1 is 2x by V1. What is T2? 3x divided by V2. What happens now is that you can see x gets cancelled. What am I left with? What am I left with is this. So I think I can just take the LCM, of course. So it will be 5 whole thing divided by. Here we have LCM as V1, V2, and this will become 2 times of V2, and here it will become plus 3 times of V1. Shift it, bring V1, V2 on the top, so it will become 5V1, V2, whole thing divided by 3V1, 3V1 plus 2V2, 3V1 plus 2V2, which is option D. Can you see that? Everybody with me? Awesome. D for doctor? Ram Ram Sarji. Yes. Yes, Satyajit for Diksha ma'am. Yes, Atuluru. Awesome. Very good. Very good. Interesting. Awesome. Moving on to the next question. Wow, we have been given the coordinates as a function of time. You give me time, I give you x. Yes. You give me time, I give you x. Yes. And where x is in meters, t is in seconds, the average velocity from 0 to 4 seconds. Average velocity. Velocity is displacement by time. Time I already know, 0 to 4. What I do not know is the displacement. Wait a minute, displacement. Displacement is change in position. Oh, yes, sir, change in position, sir. So for finding displacement, I need delta x. That means x at 4 seconds minus x at 0 seconds. When you put time as 4, see what do you get? You will get it as 7 into 4 minus 3 into 4 square minus, put time as 0. So 7 multiplied by 0 minus 3 multiplied by 0 square. Put time as 4, put time as 0 in this particular expression. So this will be 20, oops, this will be nothing but 28 minus 4 square is 16. 16 3s are 48 minus, this is just 0. So this is 48 and 28, that is nothing but minus 20. Correct? That is your displacement. But we don't have to find displacement. We have to find average velocity, which is displacement by the time interval. Displacement is negative 20. Look on the left side. That means, and the time interval is 4 seconds. So it will be minus 5 meters per second is the average velocity, which is B for your Baswa sir. Yes, B for Baswa sir, B for biology is the correct answer. Understood, guys? Yes, Gopinath, very good. Awesomeness. Satyashri, very good. Krishna, very good. Sebastian. So such a beautiful question, guys. So don't get scared when you see such variables. A lot of you might think, sir, derivatives. How many of you thought, sir, derivatives was needed here? But that's the best part. In this question, derivatives was not needed. So every time when you see x and time, don't think, sir, it is a derivative. Integration, sir, pakka, sir, integration. So that's why I left the question in the exam. Don't do such things. That is wrong. Moving on to the next concept, and that is your acceleration, which is how quickly your velocity is increasing or decreasing. How quickly your velocity is increasing and decreasing. That is a rate of change of velocity, and it is defined as delta V by delta T, which is change of velocity by time. Very simple. So just like velocity was displacement by time or change in position by time, acceleration is change in that velocity, how quickly the velocity changed. I was slow, I moved fast, in how much time. That is your acceleration. So let's take some examples to understand this. Let's take some examples to understand this. Say for example, I was going with a speed of 20 meters per second, and now I moved to 40 meters per second, and all of this happened in 2 seconds. Example, all of this happened in 2 seconds. So my acceleration will be change in the velocity is 40, which is final, minus initial, which is 20, upon the time, which is 2. 40 minus 20 is 20. 20 by 2 is basically 10. So this is 10 meters per second square. Because on the numerator you have meters per second, denominator you have per second. So that's why meters per second square. That is the acceleration. Similarly, look at this particular question. Imagine you are going with a speed of 30 meters per second. You stopped, turned, and you came back, and your speed is still 30 meters per second. A lot of students have asked, if this happened in, let's say, 2 seconds, if this happened in, let's say, 2 seconds, what is the acceleration going to be like? A lot of students tell me it is 0 because the velocity did not change. But that's wrong. See, acceleration is the rate of change of velocity, and velocity actually has changed. What hasn't changed is the speed. Speed is magnitude, velocity has a direction also. So if you notice, the direction has changed. So if a direction changes, the vector changes. So hence the velocity has changed. In fact, you have to put it with the sign convention. So my dear students, the final velocity is not 30, it is actually minus 30 because it is going towards the negative side. Minus initial velocity, it is going to be plus 30 because you're going to the positive side upon the total time, which is 2. So over here, minus 30 is minus 60. Minus 60 by 2 is basically minus 30 meters per second square. That's the acceleration. That is the acceleration. What does this minus sign tell you? This minus sign tells me that the acceleration vector quantity is directed towards the left hand side, basically towards the negative side. It is towards the negative side. If it came out to be positive, then acceleration will be directed towards the right hand side or the positive side. Also, keep in mind one important thing. Say for example, I tell you, listen, this champa is there. In this case, champa is moving this way. In this case, champa is moving this way. Why I'm drawing this and why I'm showing you this is because a lot of students think positive acceleration means increasing speed, negative acceleration means decreasing speed. That is wrong. If you are taught like this, probably you know you are taught wrong. Okay, so that is not correct. And I'll show you why also. Basically, imagine if Champa is accelerating in this direction. In this case, Champa is accelerating in this direction. Think about it. If I assume our right hand side to be the positive direction, naturally the left hand side will be the negative direction. So in this case, our velocity is positive. Here the velocity is negative. Here it is positive. Here it is negative. Here the acceleration is positive. Here the acceleration is negative because you are going towards the left side. You are accelerating towards the left side. In both the cases on the top, your velocity and acceleration are in the same direction. So your acceleration will extend the velocity's arrow mark. It will make it bigger and bigger. Your velocity will become bigger. That means the speed will increase. That means the speed will increase in both the cases. So in both of the above cases, the speed increases. The speed increases. Very, very important. Very, very important. If velocity is parallel to acceleration, or their signs are same, or their signs, positive or negative signs, are same, then the speed increases. Then the speed will 100% increase. So don't think negative acceleration means speed will decrease. No, it can increase also. It can increase also. Yeah. And the reverse also holds true in both these cases. Observe carefully. Let's say Champa has an acceleration this way. This is how Champa's acceleration is, which is negative. Here Champa's acceleration is this way, and it is definitely positive. Because acceleration is opposite, I am going here, my acceleration is there, so the acceleration will turn the direction of velocity. That means I will reduce my velocity. Just like when I throw something up, is happening. As it is going up, the speed is reducing. Why? It is moving up, but acceleration due to gravity is down. So that acceleration due to gravity is taking away, sucking away the velocity. Same thing, this acceleration will suck that velocity, and that's why it will decrease. Hence, in both these scenarios, the speed decreases. If V is anti-parallel to A, or I can just say their signs are opposite, then what will happen? The speed reduces. Then the speed reduces. And the speed will reduce. That is what it means. Is this absolutely clear? Yeah, in 1D also we should use sign convention. Yes, Abhinash. You have to. Okay, not just in 2 dimension, but also in 1 dimension. A lot of people do not use sign convention in 1 dimension. That is wrong. So going to the final thing, which is average versus instantaneous. So we just saw average was final minus initial by the time taken, which is change of velocity upon the time taken, or the time interval was delta t. So that was your average acceleration. This was your average acceleration. Same way, we can also write instantaneous acceleration. How will I write it? It will be a very small change in time. In a very, very small time, the small change in velocity, a small change in our velocity. So that's why I will write it as dv divided by dt, derivative of velocity with respect to time. dd obviously does not cancel. Small time and small change in the velocity. That's the only difference. Instead of delta, you put dv by dt, which is the derivative of velocity with time. Okay, perfect. Also, you can say acceleration, since it is derivative of time, it is also the second derivative of position. You can see why, because velocity itself is derivative of position. Velocity itself is derivative of position. So if you want, you can just write velocity as dx by dt. Just replace our velocity, which is there over here, by dx by dt, and the rest of the terms as it is. So then it also becomes dd will become d square, second derivative of position with respect to time. This is the second derivative of position with respect to time. I've just replaced the velocity term over here as dx by dt. That's second derivative. Correct. Very good. In this chapter, where do you use integration? Sweetie, we are going to come to that. Okay. Don't worry, in some time. Now, I also want you to realize the difference between uniform and non-uniform motion. You might hear these terms very often. Uniform motion means they're very simple. Yaar, what? You are moving uniformly. That means you are moving equally in same time intervals. So your velocity is constant. Acceleration is not there, right? Uniform motion means the body is moving straight line with steady velocity, like a train or a bullet train, okay, going with a constant speed for a long time. There is no interruption. Constant speed it is going. Or your aeroplane. flying in the sky. It is going with constant speed unless it has to land or some turbulence is there or it has to take off, right? It will be going in a straight line. Covers equal distances. It's similar to the actual speed of the object, and the distance time graph is straight line. Makes sense because you will be moving along a straight line. The graph will also be straight, and there is no acceleration, obviously. But when the motion is non-uniform, it can do any random thing. A plane is going in a turbulent area. So it is going up, down, sometimes increasing, sometimes decreasing. It is landing. All sorts of nonsense can happen. That is basically non-uniform motion. So uniform is when zero acceleration, velocity is constant, and I'm moving in a straight line with uniform speed without changing the direction. So that is your uniform velocity. Non-uniform is I move like this, I come back, I do like this, I go here, I go, come back, I go forward, I decrease the speed. All that sort of nonsense is non-uniform motion. As simple as that. So this brings us to the final thing, which is the equation of motion, which we are going to use completely. So ready for the equations of motion? In these equations of motion, usually what happens is you start noticing, this is basically initial or the start, and at that instant you might see the car, the pandu, the champa, the object, whatever under observation might be somewhere here, and it moves somewhere. It might go back also somewhere, doesn't matter. The displacement is s. The displacement is s. This is your displacement. And as it undergoes this displacement, there is also some kind of an acceleration which is involved, some kind of acceleration which is involved. And here there might be some initial velocity. This is initial velocity. And this after some time, it might have some final velocity. This is at time t. This is your final or basically current velocity. All these variables are related to each other. All these variables are related to each other. And how are they related? That's exactly what we are looking for. Number one. Number two, whatever we write in this entire set, no matter what, one thing will remain constant, and that is acceleration. This is very, very important, guys. If acceleration is not constant, then none of the equations which I'm going to show you will be ever true. So keep that in mind. They are only true when acceleration is constant. Exactly. Okay, great. So let's see what those equations are. And in fact, that is a question in NCERT exercise 2.2. Obtain the equations of motion for constant acceleration using the method of calculus. Ready for it? Using the method of calculus, guys? Let's try this out. We might need many pages also. So let's start with it. Acceleration is constant and acceleration is dv by dt. Perfect. So here is what I'll do. Acceleration is dv by dt. Take dt on the other side, therefore dv will be a times of dt. Now the moment I see this, I feel like integrating both sides. Let's do that. Therefore integration of dv. A is a constant, so I can always bring it outside the integration, a into dt. That is what I can do. And when I do this integration, I'll do it with limits. When time is 0, then the velocity is not 0. Velocity is how much? When time is 0, velocity is how much? It is u. And when the time is t, what is the velocity? It is basically v. So these limits are given in a corresponding manner. Meaning when this is happening on the right hand side, what is happening on the left hand side? You can't mix them up. That will be bad. All right. Very good. Everybody is ready. Very good. Sebastian, Naina, Chandana. Awesome. Awesome. So for non-uniform motion, we can't use, yes, Abhinash, we can't use these equations for non-uniform motion. Acceleration is constant. That means this is uniformly accelerated motion. For uniformly accelerated motion. Uniform acceleration. That means acceleration is not 0. Acceleration is constant. That is the main idea. What is the integration of dx? If you remember the formula, then you will get it, guys. It's not that difficult. Integration of dx is just x. correct? Plus c, but that is for indefinite. For definite, that constant won't come. So this will be nothing but v. I'll put the limits over here, u and v. Here also dt's integration by this will be just t, and I'll put 0 and t over here. First put v instead of v, then put u instead of v, and then subtract. Then put t instead of t, then put 0 instead of t, and then subtract. So therefore, taking u on the other side, I'll get v is equal to u plus at. V is equal to u plus at. Now this is our first equation of kinematics. This is our first equation of kinematics. Everybody clear? Thank you, Chandana. Thank you so much. Okay, this is our first equation of kinematics. Now let's go to the next equation. Final velocity was initial velocity plus acceleration into time. Now for the second one, what I will do is observe carefully. I'll write the first equation as dx by dt. So therefore, dx will be equal to v times dt, but v was u plus at into dt. Therefore, it is u dt plus a times t into dt. That was your dx. I feel like integrating it now. So guys, what I just did, I put dt on the upper side, and I'm just expanding v as u plus at using the first kinematic equation. Integrate both sides. So integration of dx is u is just a number, so bring it outside the integral, plus a is also a constant, bring it outside. T dt, always start with limits 0 t, 0 t. When time was 0, the position, I will just call it as x1. When the time was t, the position was x2. Perfect. So what is the integration of dx? It is just x limits x1 with x2. This will be u. Integration of dt will be just t, 0 and t plus a into x raised to 1. Integration is x raised to 1 plus 1 by 1 plus 1. So it will be t raised to 2 divided by 2 using x raised to n formula. This is 0, this is t. Now, what will I get over here? First put x2, then put x1. So it will be x2 minus x1 is equal to, then put t, then put 0. So u into t minus 0 plus here a, then put t, and then put 0. This is what I'll get. X2 minus x1, change in the position. What is it? Displacement. So this is s. What is this? This is ut plus 0 is gone. So it will be half a t square. This is your second equation of kinematics. What is this? This is your second equation of kinematics. Very good. Excellent. Yes, it is very easy when you know the basics. Yep. But I hope you have watched my class of basic maths over here. I had conducted it, okay? It's in fact there in the home page also. You can just go to the home page, guys. It's there, okay? Basic algebra, basic geometry, derivatives, and integration. I have conducted all these classes. You can watch it in case you have missed any of the mathematical classes, so that you don't hesitate in solving these questions. Then, let's go ahead. What will we do? After second equation, we want to go to the third equation. So for that, here is what we'll do. V multiply it with v only. So v was u plus at, again into u plus at. Okay. So now v into v is basically v square. And using this, you can get the answer. But is there some another way using calculus? Because they have said calculus, right? So this is your 9th or 10th standard method, which many teachers will teach you. But since it is calculus, so I want to do it using the calculus way. So here is what I will do. A is dv by dt. I will use chain rule and I will write it as dv by dx into dx by dt, which is then dv by dx, and dx by dt is velocity. Perfect. Move this around, so it will become, therefore, v times of dv will become a times of dx. Perfect. Now let's integrate it. So therefore, integration of v times of dv is equal to a is a constant, bring it outside, integration of dx. Limits are very important. So this is x1 to x2, initial to final. Initially velocity was u, finally it was v. Therefore, integration of v, integration of x is x square by 2 using x raised to n formula. So this is v square by 2. Limits are to be put, u and v. A is there. Integration of dx is just x. So this is x1 to x2. First put v. So v square by 2. Then put u. U square by 2 is equal to a into x2 minus x1. Now I can take 2 on the other side. So it will become v square minus u square is 2 times a. What is x2 minus x1? x2 minus x1 is s, displacement, final minus initial. So therefore, v square is equal to u square plus 2as. So that's it. That is your third kinematic equation. This is your third kinematic equation. We got it. Perfect. Such an amazing, amazing, amazing movie. There is one more equation, that is your fourth kinematic equation, which is called for the displacement in the nth second. Now, what is the meaning of this nth? Let me tell that to you first. See, when I say 7th second, it means take 1 second before 7, which is t is equal to 6, till 7. How much I have moved? That is your displacement in the 7th second. How much is the displacement in the previous second? Similarly, if I say displacement in the 154th second, it means go 1 second before when t was 153 and then come to t is equal to 154. How much did you move in that much time? That is your displacement in the 154th second. Similarly, if somebody tells you displacement in the 8.4th second, go 1 second before. So that is basically t is equal to 7.4, and now come to t is equal to 8.4. So in this 1 second interval, how much did you move? That is displacement in the 8.4th second. Got it, everyone? This is how it works. So when I want to look at nth second, here is how I will look at it. Maybe from t is equal to 0 to some point over here. This is t is equal to n. And let's say from t is equal to 0 to this point over here. This is n minus 1th second. This was at t is equal to 0. So this much is nth second. So from here to here, whatever displacement is there, this is your displacement in the nth second. This is your displacement in the second. So clearly it is seen displacement in the nth second is this whole yellow line, which is displacement in n seconds, minus, from this take out this part, so minus displacement in n minus 1 second. In the 7th second, the displacement is 8 seconds displacement minus the 7 seconds displacement, whatever is remaining. That's all. So now you just have to substitute everything. Let's see. So Sn will be using ut plus half at square formula, un plus half a n square. Then minus sign. This will be u into n minus 1 whole square plus half a into n minus 1 whole square. That's it. So I think we should expand this because this is fine. This is the main problematic part. So this will be u, so it's ut plus half at square. So this will be un minus u plus half into a. N minus 1 whole square is n square plus 1 minus 2n using a minus b whole square formula. Okay, so this is what I will get over here. So next step, so what did I put u for? This is u into n. All right. So now the next step will be un minus u plus, this will be a n square by 2 plus a by 2 minus 2 cancels a n over here. And what is there on this side? Here we have basically un plus half a n square. See, many things will get cancelled over here. Many things will get cancelled, like this un and this un will get cancelled. half an square, and this negative half an square will also get cancelled over here. So I'm just left with these terms over here. If you notice, what is left over? Just check this out. What is left over? What is left over? U is left. U is left, correct? Minus minus will become plus, and then I'm left with negative a by 2, and minus minus again becomes plus, and this will become plus an. You can take a common, and you will get the final answer now. Yes, this will be nothing but u plus a by 2, you take out common and write it as 2n minus 1. It's one and the same thing. 2 cancels, it will become an, and over here you just have minus a by 2. Perfect. So this is the displacement in the nth second. This is our fourth equation. What is this? This is our fourth equation. This is our fourth equation of kinematics. All these four equations are very important. Cool. So I've done the derivation for all of you. Okay. In case of any problems, you can always rewind it, and especially useful for your boards maybe. But why is it important for NEET is because you get the habit of integration from here. You understand how integration works in this particular derivation. So that is the reason why you should do this problem. Otherwise, NEET will not ask you derivations, but it is useful for problem solving. That is the reason why you should do this. So these were the equations of motion, which I can put it on the next slide, which is already there. Yep, over here. Yeah, cool. Let's do some questions now. Always use sign convention, okay? All these are vectors, so you have to use sign convention. Treat something positive, something negative. Everything will come properly if you follow our signs. Let's do this. Coming up on your screen, here is the first question. So, read the question. See if you can do something about it. See if you can do something about it. Very good, Krishna, Nana, Divya. Thank you so much for your hearts and love, guys. Thank you so much. Keep the chat box alive. Understood. Very good. Okay, a particle is moving with some velocity along positive direction, acceleration of 1 along the negative x. Find the distance traveled by the particle in 10 seconds. Interesting question, guys. So the particle is initially going with a speed of 4 meters per second, but clearly it is mentioned the acceleration is on the negative side. So our acceleration is here of 1 meters per second square. So 100% the speed will reduce. Do you guys agree with it? So speed is reducing. The speed is reducing. So if speed is reducing, some time or the other, it will 100% become 0. It will come to rest. Can we find when does it come to rest? I think so. Let's use which equation? I know acceleration. 1 meters per second square. 1 meter per second square. I know initial velocity, final velocity. I need the time. Which equation can we use? I think it should be v is u plus at. So final velocity is initial velocity plus acceleration into time. Finally, I'm coming to rest because speed is reducing. Initial velocity is 4 plus acceleration is -1 because it is this way into time, and whatever that time is, we'll figure out. So therefore, t is basically 4 seconds. You know why I found out the time when it is stopping? Because I just wanted to check in this 10 seconds, does it even stop or no? Because I know many of you will be wondering, sir, what nonsense are you doing? Can't you just use S is ut plus half at square? Is this right in this problem? Just read the question again. I know many of you said or thought about this, like I'm pretty sure Sleet Sheet also thought about it. S is ut plus half at square, but that is wrong. You know, that is wrong. Why it is wrong is because, read the question, it says distance. And when I use S, it is displacement. So that is the problem. That is the problem. So you cannot use it. So please remember, I can't use S is ut plus half at square because this is distance, this is displacement. Be careful. Two different things. And maybe if you are turning, if you are stopping and turning around, your distance traveled will be more, displacement will be only this much. That is why you cannot use it. That is why you cannot use it. Is this clear? Why you can't use it till this point? Perfect. So now let's solve what happens for next. Once it stopped, till it reaches 10 seconds, more 6 seconds will go. So in those 6 seconds, maybe it has reached here. And in basically the next 6 seconds from rest, and it is still accelerating with 1 meters per second square. Okay, interesting. So in this duration, how much displacement does it do? Displacement in those 6 seconds. Displacement in those 6 seconds. Initial velocity into t plus half into a into t square. If I use it, initially it is 0. Acceleration is basically, if I take this direction as negative, it will be -1 into time, which is basically 6. 36 by 2 is basically -18 meters. So I have gone 18 meters like this in the negative direction. Awesome. And while stopping, how much distance have I traveled? I can find it out using either S is ut plus half at square, or v square is u square plus 2s. So if I use v square is u square plus 2s, final velocity 0, initial velocity 4, acceleration -1, displacement I want to find out. So therefore 4 square is 16, 2 into S1 will come on the other side. So therefore S1 is basically 8 meters. So I have gone here 8 meters. So I have gone like this 8 meters, stopped, turned around, and then from here to here I have gone 16 meters till I reach here. So how much would be my displacement? This is my displacement, guys. This is my displacement. So guys, my displacement will, sorry, this is not 16, this is 18, my bad. This is 18. So it will be nothing but 18 minus 8, which is basically 10 meters, which is basically 10 meters to the left. 10 meters to the left. If you want, you can also write S as -10 meters. You can also write displacement as negative because it is towards the left. As simple as that. Understood why you cannot use that and how we broke down the question into small parts? Because distance was asked. If distance was asked, or displacement was asked, accordingly things will change. So displacement will be -10. But if distance is asked, like in this particular question, so the distance traveled will be 18 plus 8, which is 26 meters. So the distance traveled answer is 26 meters, whereas displacement will be -10. Cool. So we have done this problem properly. Moving on to the next question, answer is 26. Moving on to the next one, the initial velocity of the particle is 10, retardation is 2, distance moved by the particle in the 5th second. This was asked in PMT 1976. Wow, very old, but still, I want to see if you are in that age, will you be able to crack this within 30 seconds or no? Come on, in next 30 seconds, I want every one of you, even if you're watching it recorded, to crack this question and give me the answer. Come on, guys, PMT 1976. Displacement in the 5th second. Question is very straightforward. Formula is there with you. Thank you, Chandana, for all the hearts. Thank you so much. Thank you, Krishna, Warrior Pandu. Yes, think about it. What is the answer for this? Use the formula. What is the formula? U plus a by 2 into 2n minus 1. That's it. So u plus a by 2 into 2n minus 1. What is initial speed? 10. What is acceleration? Oh, it is retardation. That means negative. And n is 5 minus 1. So if you miss this minus, you will get wrong answers. So 10, 2 cancels minus. So 2 5s are 10. 10 minus 1 is basically 9. So it should be basically 1 meter. Just check this out. Yes, that is the answer. A for AIMS. Very good. Pratibha, oops. Many of you made a mistake. What did you miss? Why did you write B? Because you miss this word. That's how the examiners trick you. That's why you should read carefully. You should never overlook the information. Always be careful. Got it? What a question, right? Very nice. So let's solve a question on stopping distance now, where you will see that you are moving with some speed and you see something, some obstruction, something has gone wrong. So you will apply the brakes and you will stop. Okay. But before you apply the brake, there is always something like reaction time also could be involved, depending on, how sensitive the driver is and how your reflexes are. Some people are like, when they see a car in front or some obstruction, I've seen some Instagram videos, they start screaming. They feel that if they scream, the vehicle will stop. I've seen one video. And I saw one video where that person was screaming and instead of pressing brake, they are accelerating also. And they dashed into that another thing. I'm very scared of such people. Yes. So, I had also seen one video of Formula One, race where there is a car in the tunnel, it has broken down, and there is another car which is coming inside the tunnel, and the driver reacted so quickly, just within a fraction of a second, moved aside and went. And this was happening at speeds above 300 kilometers per hour. So imagine you are going 300, 200 kilometers per hour, you see some obstruction immediately and not very far. It's a turn inside a tunnel. Imagine in a tunnel, there is complete blind spot. You cannot see anything. Suddenly you see the vehicle, you immediately turn and you react and you go without dashing. That is the kind of reflex which is there with F1 drivers. They're very quick in deciding things. They act very quickly, or else it's a matter of life and death. So this is your reaction distance. Usually this should be as less as possible, and braking distance obviously should be also less as possible. This depends on whom? What does this depend on? This person sitting inside. This depends on whom? The person partially, I mean how much you apply the brakes, but also mainly depends on the car. If the car is good, then braking distance will be very less. If the person inside is a fool, then forget the reaction distance. This braking distance will not be braking, it will be accelerating distance. The car will hit this poor antelope, this will be flying in the air. So it will fly in the air with an angle of 60 degrees with a speed of 100 meters per second. Where will it land? We'll solve that in the next chapter, motion in 2 dimension. That will be motion in 2 dimension. Okay. All right. Great. So let's see, a car moving now is in a straight line in a highway with some speed, is brought to a distance, stopping distance of 200 meters. What is the retardation of the car? First of all, convert this kilometers per hour. The moment you see this, no, usually you will try to convert it by multiplying by 5 by 18. Okay, just see how much it is. Multiplied by 5 by 18. Come on, my dear warriors. How many meters per second is it? Quickly. Hmm. How many meters per second? Whenever you see kilometers per hour, multiplied by 5 by 18. Yes. How much is it? 35 is it? Paka. Meters per second. Yeah. 18 sevens are. Hmm. Okay. Now, to read the question. Now read the question properly. Okay. It stops within a distance of 200. What is the retardation assuming uniform, and how long does it take for the car to stop? Okay. So the car was going at 35 meters per second. It takes some time for the car to stop. Okay. And this distance is given to be 200 meters final velocity, initial velocity, distance. I think the third kinematic equation. So if I use v square is u square plus 2as. Final velocity is 0, initial velocity 35 square plus 2 into acceleration, don't know, displacement 200. Perfect. So guys, this will become 400a is equal to 35 square is equal to 35 square. So acceleration, come on my dear warriors, find it out. Find out the acceleration quickly. I want to see how many of you are really quick about this. Come on my dear warriors. Come on my dear warriors. 35 square, how much is it? 1225. Yes, perfect. divided by 400, 1225. Chandana, to meet me, you'll have to come to Bangalore. Yes, Bangalore office. Or when I come somewhere, then you will, uh, for some meetup, you can meet me in Chennai, Hyderabad. Yep. Yeah. So divided by, how much is it? 400. So how much does it approximately come out to be? 1225. It will be almost like, because 1200 divided by 4 will be 300. So more two zeros. So 3. So very close to 3. Approximately 3 meters per second square. But with a negative sign. But with a negative sign. Is that right? Why is this negative? Because it is retardation. Because it is retardation, hence negative acceleration will be there. Hence negative acceleration will be there. Perfectly fine. How much time does it take to stop? I can use S is ut plus half at square, V is u plus at. All these things we can use. Yep, perfect. So let's say we use V is equal to u plus at. Final velocity 0, initial velocity 35, acceleration is negative 3 approximately into time. So therefore, our 3 times of time will be 35. So time will be slightly less than 12 seconds, slightly less than 12 seconds, correct? So how much will it be, guys? 11 point? How much will it be? Yes, approximately it was minus 3, correct. So divided 35 divided by 3, how much is it? 11.667 approximately you can put it. Yep, very good, very good. 11.667, or you can just put it as 67 seconds. Perfect. That is the answer. So it takes this much time to stop. Awesome. Very good. And they have put some weird answer. Why did you put 11.4? That is wrong. That is 11.6. All right. The ratio of the distance traveled by a free falling body, first second, second second, third second, and fourth second. This is asked in NEET 2022. Now, although many of you might have by-hearted the answer, let me show you a very interesting uh, way later on. But this is also called as Galileo's law. I will show the proof of it after some time in the graphs part. So this is also called as Galileo's odd ratio for uniform acceleration starting from rest. This is very important. If you start from rest, you start from rest and you moving for some time and you move a distance x in time t. In the next time, when the time will become 2t, you would have moved 3 times of the previous one. This is at t is equal to 2t. In the same interval again, now you would have moved 5x when the time will become 3t. So in one time interval, if you have moved some distance, in the next interval, equal interval, you will move 3 times. In the next interval, you will move 5 times. In the next, you will move 7 times. So equal intervals, equal time intervals, the displacements are in odd ratio. The displacements are in odd ratio. So hence it will be 1 is to 3 is to 5 is to 7 is to 9 is to like that 11. Okay, so it is always C for captain. Shreyas, yes, Atluru. Correct, Divya, very good. Krishna, very good. Srividya, Aren, yes. No, Chandana, it is not squares, it is odd numbers. Pavitra, yes, perfect. Pratibha, yes, perfect. Awesomeness. Very cool, guys. Awesome, 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 awesome. Proud of all of you. Proud of all of you. Very good. Keep it up. Moving on to the next question. A particle, this is again based on Galileo's law. A particle starting from rest moving with constant acceleration travels a distance x in the first 2 seconds, a distance y in the next 2 seconds. Then how are these two related? Look at the question, guys. It travels a distance x. It's starting from rest. It travels a distance x in the first 2 seconds. This is from t is equal to 0 to t is equal to 2. In the next 2 seconds, that means the same interval, it will travel a distance of 3x. So this will be t is equal to 4. Next 2 seconds, this is given to be y. This is given to be y. So y is 3 times of x. This was also asked commonly in many competitive exams. Yep. This is also C for Captain Shreyas. Perfect. Awesome. Awesome. Now let's come to graphs. Let's come to graphs. And we'll see all these graph-based questions also. Okay? Get ready for it, my dear students. A lot of graph-based questions are coming now. But let's understand the calculus relations, and then we'll see the graphs part also, area, slopes, etc. How many of you have seen my derivatives and integration class? Quickly light up the chat box. How many of you have seen my derivatives, basics of maths, derivatives, basics of basic maths integration? How many of you have seen that? Quickly light up the chat box with some fire emoji, or put up a heart, or put up a smiley, guys. If you have seen this, this will be easy. Else you will be like, sir, what is happening? Sir, what is that formula that you just used? Can you please tell me? So very good. Pavitra has seen. Very good, Lakshmi. Very good, Satyashri. Awesome. Awesome. If you know it also, very good. If you have seen it before, long time, some old class, that is also okay, guys. As long as you know about those derivatives and integration, okay? Very nice. Awesome. Awesome, Jay. Very good, Chandana. Very good, Pratibha. Satyashri, Aaron, Divya. Great. So, let's learn this now. See, when we saw x, which was nothing but our position, and I want to go to velocity, and then I want to go to acceleration. If I go from here to here, basically you just have to do dx by dt, derivative of x with respect to time. So it is rate of change of x with time. It will give you velocity. So this is rate or derivative of x with respect to time gives you velocity. The same thing you do over here. You do dv by dt, you get acceleration, which is again the rate or the derivative or differentiation, derivative of velocity with respect to time. Obviously, integration is antiderivative of this. Hence, when I go from acceleration to velocity, I usually will integrate. So acceleration with respect to time. If I integrate it with proper limits, I don't exactly get velocity. I'll get change in velocity. So if I just integrate it without limits, I will get velocity. Please mind it. There will be also some constant of integration. But if I integrate it with limits, very, very important, acceleration with respect to time from t1 to t2, this is what gives me delta v, which is change of velocity, change in velocity. So if you do indefinitely, you will get velocity. If you do it definitely with limits, you will get change in velocity. Be very careful about this. I'm telling you, I'm warning you. This is integration, okay? The reverse, the antiderivative. Same thing when you go from here to here. The same thing when you go from here to here. If you integrate velocity with respect to time indefinitely, you will get the value of x. But if you integrate velocity with time with limits t1 and t2, what you will get is delta x, which is change in position. Change in position. And do you remember what is the term for change in position? It is nothing but called as displacement. There is no term for change in velocity, or else we would have written that also. But for change in position, the terminology used is displacement. This is what it looks like. These are all derivatives. You go reverse, it is antiderivative. I've given you the list of all the formulas, previously, so you can use them as well. Great. So now, if I know this till here, there is one last thing which I will tell you, okay, which is also very important certain times. This acceleration, especially, which is dv by dt, okay, you can write it in many different ways. Dv by dt. This velocity I can write it as derivative of x with respect to time. So I can just write it as second derivative of x with respect to time. This is one way. Another way of writing that acceleration is using chain rule. I can use, I don't have space now over here. Let me write it somewhere else. I can also write acceleration as dv by dt, but at the same time, I divided by dx, multiplied by dx using chain rule. So what I get is dv by dx, dx by dt is velocity. So this is also an important formula. Acceleration is v dv by dx, or acceleration is second derivative of time. All these things might be useful at some or the other place. Let's start with some questions. My dear students. So, in fact, okay, let's start doing this. Okay, X is given as this is NCERT question. X is given as this: A is 8.5, B is this much, T is measured in second. What is the velocity at 0 and 2? What is the average between 2 and 4? Okay, thank you, Krishna, for reminding me to drink water. Let me just drink some water and come. Just hold on. Let me just drink some water. Meanwhile, you just solve this question. All right, so that was your water break. Let's have a look at this particular question. Where did my pen go? Yes. Hmm. What is the velocity at 0 and 2 seconds? Okay, so let's start with this. If I want to find velocity from position, I need to find the derivative of it, right? From position, I want to go to this, I want to find the derivative. Okay, so v is the derivative of x with time. So it is the derivative of x. X is basically a plus bt square. Now it will be derivative of a constant plus b is a constant, so it comes outside, and derivative of t square. Derivative of a constant is 0 plus b into t square's derivative. X raised to n's derivative is nx raised to n minus 1. So 2 into t raised to 2 minus 1. So hence the answer is 2 times of b into t. So that is your velocity. But you have to find the velocity at 0 and 2. So therefore, what I will do is putting time as 0 in this particular equation, V0 will be 2 into B into 0, which is 0 meters per second, and velocity at 2 seconds will be 2 into B into 2, which is 4 times of B, but B value is 2.5. So 4 into 2.5, which is 10 meters per second. So we found these two answers. So this is done and this is also done. Okay. Now let's go to the last part of this problem where you have to find the average velocity. To find average, I need the displacement. And to find displacement, I need the positions. So let's find out what is x0 and what is, sorry, not x0, x2 and what is x4. X2 means putting time as 2. So it will be a plus b into 2 square, which is basically a plus 4b is x2. Similarly, x4 will be a plus b into 4 square, which is 16. So a plus 16 times of b, that is your x4. So I found x2, I found x4. These are the positions. Subtracting them, I will get displacement. So the displacement will be x4 minus x2, which is a plus 16 times of b minus a plus 4 times of b. A cancel, 16 minus 4 is 12, so 12 times of b. That is displacement. I want to find the average velocity. I want to find the average velocity. So it will be 12b divided by the time from 2 to 4. From 2 to 4, how much is it? It is 2 seconds. So 2, this will be 6 times of b. Exactly, this will be 6 times of b. Everybody with me? Yep. Awesome. But I know the value of b. B is 2.5. So it will be 6 multiplied by 2.5, guys, which is nothing but 15 meters per second. So that is that answer. So we found out everything, instantaneous, average, everything using derivatives and simple knowledge. Awesome. Very good. Very nice. Proud of all of you. Proud of all of you. Very good, guys. Let's go to the next question coming up on your screen, and here it is. In NEET 2024, that's this year it was asked, the particle is going in the x direction. It changes as follows: ratio of initial velocity to initial acceleration. Oh, ratio of the initial velocity to the initial acceleration. So I think we have to find two things here. First, let's find velocity, which is derivative of x with respect to time. That means you have to find the derivative of alpha t raised to 4 plus beta t raised to 2 plus gamma t plus delta. So it will become alpha into derivative of t raised to 4 plus beta into derivative of t square plus gamma into derivative of time plus derivative of a constant is 0, correct? So that will go off. So this will become alpha into 4 into t raised to 3 plus beta into 2 into t plus gamma. This is your velocity. So initial velocity, just think about it. What will be initial velocity? Initial velocity means time is 0. So here it is 0, here it is 0. I'll be just left with gamma. So initial velocity is just gamma. Initial velocity is just gamma. Proceeding little bit ahead towards acceleration. Acceleration being derivative of velocity with time. It will be nothing but derivative of this whole thing, which is 4 alpha t cube plus 2 beta t plus gamma. Now 4 alpha is as it is, t cube's derivative is 3t square, 2 beta t's derivative will be 2 beta, gamma is a constant, so derivative is 0. This is acceleration, but I will try to find initial acceleration, a0, a0. So put time as 0, this is 0, there is nothing to put over here, so it will be just 2 beta. So initial acceleration is 2 beta. Now the question is velocity by acceleration. So acceleration is below. So you have 2 beta over here, and initial velocity is on the top. So you have gamma. So it is gamma by 2 beta, which is D option, which is basically D option, D for doctor. Yep. Or D for your Diksha man. Perfect. Awesomeness. Awesomeness, Satishi, Erin, Krishna. Very good. Mr. Killer Rudra. Oi, Snapchatter. What is this Snapchatter? Pavitra, correct. Very good, Divya. Awesome, awesome, awesome. D for doctor. Correct. Very good, very good. Let's move ahead. Let's move ahead to the next question coming up on your screen. The velocity of a particle is given to be this, where a and b are constants, then the distances traveled by it between 1 second and 2 seconds. From velocity, if you have to go to displacement, what did I tell you? Go back. From velocity, if you have to go to displacement, you have to integrate. And especially if you want to find a displacement directly, you do integration with limits. This is what I told you. So this is a very good diagram which will help you to analyze the question. So let's go ahead and write it down over here. In order to find the displacement, I have to integrate between 1 and 4 seconds. So displacement is integral of velocity with time from t1 to t2. So velocity is basically how much? A t plus bt square, and time is 1 to 2. A is a constant, just integration of, sorry, this was into dt, a into t into dt from 1 to 2 plus b into t square is the integration from 1 to 2. So what is the integration of t? T raised to 1's integration is t raised to 1 plus 1, which is 2 upon 1 plus 1, which is again 2. Limits obviously are very important, 1 and 2. Oops. Plus b into t raised to 2's integration is t raised to 3 by 3, x raised to n plus 1 upon n plus 1, 1 and 2 over here. Therefore, displacement is first put 2, then put 1. So it will be a into over here. If you put 2 first, it will be 2 square by 2 minus, then put 1. So 1 square by 2 plus b into first put 2, then put 1. So 2 cube by 3 minus 1 cube by 3. All right. So therefore, displacement is a into 2 square is 4, 4 minus 1 is 3. So a into 3 by 2 plus b into 2 cube is 8, 8 minus 1 is basically 7. So into 7 by 3. That's it. So 3a by 2 plus 7b by 3, which is B for biology. B for Baswa sir. Correct. Subhash, now is not the time to think whether re-NEET will happen, not happen, because Supreme Court is going to take that judgment. Concentrate on study. See, if you're sure that you are going to crack it, then you don't have to worry. If you have got decently average or very low marks, then you know what you should do. You should prepare for not re-NEET, you should prepare for NEET 25. Because if you have got, see, it might feel bad, but if you have got 300 or 200 or 400 marks also, you think unless you have been preparing for the last 2 months properly and that flow has not broken, you are not demotivated, then tell me, is there a chance, even if re-NEET happens in the next 1 month, do you think from 400 you can go to 650, 660 in just 1 month? No, right? Unless you have been preparing again. So if you are preparing properly, then yeah, maybe in the 3 months duration, you could have done rigorous practice and you would have improved. But otherwise, I feel you should just worry about either NEET 25 or counseling. Okay, re-NEET, even if it happens, it depends on many factors whether you might do well or not. I'm not trying to demotivate you, but presenting the facts. Okay, so let's look at the graphs, guys, now. So let's look at the graphs. Okay, now see, just like we went from position to velocity to acceleration using derivatives, graphically, derivatives means slope. Graphically, what does derivative mean? So remember this quick thing. Derivative means slope, correct? So derivative means the slope. So if I have a graph, this is x, this is y, and The graph is something like this. I draw tangent somewhere, I measure this angle. So this slope is nothing but tan of theta. This is nothing but tan theta, and the derivative is nothing but your dy by dx. This is what it stands for. The exact reverse is for integration. So integration with limits, which is also called as your definite integration. So definite integration is nothing but area under the curve. Area under the curve, which means, say for example, you have this graph of y versus x, something like this, and you happen to measure this particular area from x1 to x2. So this particular area is integration of y with respect to this x from x1 to x2. These are the lower and the upper limits. So that is what I had told you during the basic maths class of derivatives and integration. So the same concept we will be using over here, guys, nothing more, nothing less. So if I'm going down over here, I'm just finding the slope of position versus time graph. The slope of position versus time graph will give you velocity. Okay, so slope is nothing but you draw a tangent and you measure the tan of theta with the horizontal line. Similarly, from velocity to acceleration, you find basically the slope of velocity versus time graph. When you go opposite way, basically you find the under area under acceleration versus time. Then what you get is not v, actually what you get is actually delta v. Be careful about it. What you get is not velocity, you get delta v. Please bear that in mind. Similarly, when you go from velocity to position, you are basically trying to find the area under the velocity versus time graph. And what you reach is not position, you end up reaching change in the position, which is basically displacement. So this is the main thing that you should know. This is the main thing that you should know. That's all, guys. So just to show you over here what they exactly mean. So these are some of the graphs. Here, this is position versus time. You draw a tangent, you measure the angle. So that's it. That slope is nothing but this particular tan theta. So that slope is nothing but tan of theta. Here, this is velocity versus time. You want to measure the velocity at any instant. You draw that angle by drawing the tangent. So again, that tan of theta is again the slope of that velocity time. Here, in this case, you are going to find the area under the graph. So you will be basically integrating it from some time to another time. That's it, guys. So you will be just trying to find the area under velocity time. That will give you the displacement. Area under acceleration versus time, even if acceleration is not constant, that will give you how much is the change of velocity. So this was giving you basically displacement. This was giving you basically delta V. So these are the graphical meanings of that calculus part. These are the graphical meanings of those calculus parts. So now, if I tell you, say for example, this is position time, this is velocity versus time, and this is acceleration versus time. You can also extend it below. quickly think and tell me, what does this graph represent? Quickly think and tell me, what does this graph represent? See, if I draw a tangent to position time, the tangent will be parallel to the horizontal line, so there is no angle made. So tan of 0 is 0 degree. So basically, this just means velocity is just 0. Is that right? So if I draw a horizontal line like this, that's it. It just means my velocity is 0. Same thing, if I show the graph here, this also means my velocity is 0. Correct? Now, let's say I draw a graph, let's say over here like this. If I draw a graph like this, what does it mean? If I measure the angle with the horizontal line, it is making a positive, it is going up. So that means the slope is positive. So the velocity is 100% positive. Not just that, it is a constant line. So maybe even the velocity is constant. It is a straight line. So velocity is constant. In fact, here also, if I draw a line like this also means the velocity is positive because it makes a upward angle. It is going up as I increase time. As I go here, the velocity is increasing. So that's why the velocity is positive. Whereas this graph over here, or maybe this graph over here, the velocity is negative. The velocity is negative. Understand that. Okay, so if it is going down with time the value reduces. That's definitely making a downward angle. That's definitely making a downward angle with the horizontal line, the tangent of it. Hence, the velocity is negative. Clear? Similarly, my dear students, if I show a graph which is like this, we all know velocity is 0. If I show a graph like this, we know velocity is positive, and not just that, it is also a constant. But if I show a graph which is like this, it means the velocity is tangent. No matter where you draw, it is upwards, so it is positive also, plus the steepness is increasing, so velocity was positive and it is also increasing. It is not constant, rather it is increasing. Do you see that? Everyone with me? Velocity is increasing. Very nice. Same way over here, imagine if I draw another graph. Which is something like this, if I show it like this, here if I draw a tangent like this, then here, then tangent like this, do you see the tangents first was like this, then like this, then like this? The slope is reducing. But the tangent is still pointing upwards, so it is going to be positive only. The tangent is still pointing upwards, so it is still positive. So velocity is positive but decreasing. It is decreasing slowly. I am stopping. I mean, I'm still moving positively. I was moving very fast. Now I am slowly stopping. I'm retarding and slowly stopping. That's what it means. Is that understood, my dear warriors? Same way, I can draw a graph maybe like so. Here the tangent was like this. Here the tangent is even more steep. So it is pointing down. If I draw the tangent, it is pointing down. So here in this case, the velocity is negative. In fact, it is becoming more and more negative. It is becoming more and more negative. And it is not a constant, guys. It is not a constant. All these are non-uniform, either increasing, decreasing, except for the green and the blue one. Everywhere the velocity was changing. Correct. Awesome. Also, you will see, like I said before, this is for rest. This one or even this one, velocity is constant, but acceleration is 0. But things like this, here velocity is not constant. Definitely acceleration is there. Acceleration is not 0 in these graphs. So they are non-uniform motions. They are all non-uniform motions. This was uniform motion because velocity was constant and acceleration was not there. But in these graphs, there was acceleration because velocity is continuously changing. Velocity was continuously changing. So understand, whenever we see position versus time, what are we exactly referring to? We are seeing position times slope is giving me velocity. If the tangent drawn is same everywhere, that means the slope is same, that means velocity is same. But if the tangent drawn is different, oriented, angles are different, then you will see that the velocity is changing, and whenever velocity changes, there is some acceleration. So that is why in these graphs, like the blue ones, you saw velocities tangents were pointed upwards. Velocities tangents were pointed upwards, so that's why it was positive. But here the tangent was slowly going more and more up, that's why increasing. Here the tangent was going up, but now not so much up, so it is decreasing slope wise. That's how you look at it. And whenever it is moving randomly, it is non-uniform, it is definitely going to have some bit of acceleration. Understood? Jyotiradya, Siddheshwar, everyone clear? Okay. Same way for velocity, guys. Let's say if I show a graph like this, that means velocity is 0, it is at rest. That means no velocity exactly. But if I show over here, then velocity is positive, it's on the upper side, as well as constant. Not just that, because it is constant, there is no acceleration. It's going constant velocity, so no acceleration only. Same way, if I show the graph over here, then the velocity is negative, but it is still a constant. That means acceleration is still not there. There is no acceleration only. Think about it. Velocity is constantly negative. Some negative value will be there here. -5, -3, this is 0, this is positive. Got it? Whereas if I show the graph like this, velocity is now changing. It is not a constant. So velocity is definitely not a constant. In fact, the tangent drawn makes a positive angle. The tangent which is drawn makes a positive angle. Hence, it is having a positive slope. What does the slope give you? Acceleration. So hence acceleration is positive. It has positive acceleration. Same way, if I draw a graph which is, let's say, like this, or even like this, then you can see again velocity is 100% not a constant. It is continuously changing from positive to negative or whatever. And the graph's tangent is on the negative side. So it is negative slope. That means acceleration is negative. That means the acceleration is negative. Correct. Very good. Awesome. All these are very, very interesting things. Finally, for acceleration, also we can do some cases. If it is flat on the time axis, acceleration is 0. That means the velocity is a constant. I don't know what the velocity is, but it is not changing it. If I show the graph over here, that means acceleration is positive and it is constant like this. If I show the graph over here, that means acceleration is negative and a constant. That's all. It is constant. But anything else, if I show something like this, then acceleration is not a constant. Then acceleration is not a constant, some non-uniform motion. So this is 100% a non-uniform accelerated motion. Non-uniform accelerated motion. Got it, everyone? Okay, let's see some questions now. Okay, let's see some questions now. Let's have a look. Here is the first question. This is there in Tatva book. Draw the velocity time graph for uniformly acceleration, then moving with uniform velocity, and then retarding for velocity versus time. Okay, velocity versus time. So let us draw the time axis. Let us draw the velocity axis. This is 0. First, what is happening? Accelerates uniformly. If acceleration is there, that means velocity is changing. But should I draw the graph curved or should I draw it straight? Because it is mentioned uniform, that means velocity will change at constant rate. So that's why I'll put it like this. And initially the body was at rest, from rest. So velocity was 0 when time was 0. It reached some value. After reaching some value, it moves with uniform velocity. So uniform velocity. So v was constant over here. Here acceleration was there. In fact, it was positive acceleration. Then it retards uniformly. That means negative acceleration is there. So acceleration will be negative till, let's say, it stops over here. So the graph will be like a trapezium. The graph will be like a trapezium. Correct. Very good. Excellent. That's the correct answer. Moving on to the next one. Which of the following graph represents uniform motion? Which of the following graph represents uniform motion? These are all displacements time. Uniform motion, guys. This is at rest. If you see, the coordinates are not changing. So this is definitely at rest. Here, moving front and back. So direction has changed. Here, the tangents drawn are obviously making different angles. So velocity is definitely there. And not just that, the velocity is also not constant. It is changing. So velocity is not a constant. Only in this, it has got a constant slope. Constant slope. If you draw a tangent to this, the angle is the same. So hence, velocity is a constant. So hence, it should be option number A. Hence, it should be option number A. How many of you wrote A for Ames? Wow. Very good. Very good. Perfect. Moving to the next question. The displacement graph is shown. The instantaneous velocity is negative at which point? Displacement time, position time. If you draw the tangent, the slope gives you velocity. So where is the velocity negative? Think about it. If you draw the tangents here, or even here, or even here, it is going up. It's positive. I think if you draw the tangents here, or even here, or even here, it is going down. And again, here or here, it is going up. So I think it is going down over here. If you see, it is going down over here. It is going down over here. So it is definitely negative slope. It is definitely negative slope. So at point E, which is basically option number C. So option number C, point E. The slope is negative, and that means the velocity is also negative. Yes, Arthluru. Yes, Divya. Oh no, Divya, it's not B option, it is C option. Yes, C for Captain Shreyas. Yes, Atyashri. Yes, Krishna. Correct, 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 Pavitra. Awesome, awesome. Moving on to the next question on your screen now. The variation of the velocity of the particle with time along a straight line is illustrated in the following diagram. The distance traveled by the particle in the 4 seconds is the distance traveled by the particle in the 4 seconds. Guys, velocity to displacements, distances, positions mean you have to find the area under the graph. Okay, so till 4 seconds, you have to find all the areas. First, find how much is this area. How much is this area? This height is 10. This base is 1. So this area will be 10 into 1, which is basically 10. Correct? This is basically 10. Great. Then also find this particular area. This particular area. This base is 1. This height is 20. So it will be 20 multiplied by 1, which is basically 20. Then look at this triangle. Look at this triangle over here. Half into base into height. Base is 1. Height is 20. So it will be 10 again. Now this is a trapezium. Now I don't know if you remember the formula for trapezium. Area of a trapezium is half into the sum of parallel sides multiplied by the height of the trapezium. This is what the formula goes. So over here, notice this is the height. This is the height, which is basically 1. This is one parallel side. This is one parallel side. One of it is 10, other is 20. So when you try to find this area, half into sum of the parallel sides, which is 10 plus 20, into the height, which is 1, which is the distance between the two parallel sides. 20 plus 10, 30. 30 by 2 is basically 15. So now the question is, what is the distance traveled. So the distance in this case is also the displacement, which is basically area under velocity versus time. So it will be 10 plus 20 plus 15 plus 10. 20 plus 10, 30, 30 plus 15, 45, 45 plus 10, 55. So answer is 55 meters, which is B option. Yep, it is B option. Got it? Very good. Awesome. So you should know this formula for area of a trapezium is half sum of parallel sides into height, or else many people split it into triangle and rectangle, which is also fine, but it is going to make the process lengthy. Why would you do that? Why would you do that? Okay. So no need of that. Okay. Moving on to the next question, which is asked in NEET 2022. There are two graphs given for displacement time. One is making 45, another is making 30. So what is the ratio of the velocity? Guys, whenever displacement time, position time, and velocity is given, velocity is nothing but the slope of your position versus time or displacement time. That's it. So velocity for 30 degrees upon velocity for 45 degrees. Just see, this is the tangent, this is the angle, this is the tangent, this is the angle. So tan theta by tan theta. So this will be tan 30 by tan of 45. Tan 30 is 1 by root 3. Tan 45 is 1. So answer will be 1 by root 3. So 1 is to root 3 will be the answer, which is C for Captain Shreyas. Yep, C for Capto. Awesome, awesome, awesome. Very good, very good. Great. Moving on to the next question, guys. See, this is how graph questions are. They're not very difficult. If you know the theory, it's very easy. Particle, this is also PYQ from 2008. Distance time graph, maximum velocity instantly is around which point? So velocity is again the slope, how steep it is, right? Tan theta, tan of theta, slope of your position versus time. So over here, if you draw the tangents, it will be very, very obvious where is the slope highest. Here it is like this. Here it is probably at point B, it is like this. At point C, it is even like this. At point D, it is like this. So where is the angle maximum? I feel this is the maximum possible thing. Rest all are okay. I mean, this is decent. This is still okay. And the worst one is like A. So A has the least. So I think the maximum angle is for point C. So theta is maximum. So tan theta is also going to be maximum. So velocity at point C is also going to be maximum. So it should be point C. That means option B. Option B is the correct answer. Option B is the correct answer. Yep, B for Baswa sir. Correct. Very, very, very good. Very nice. Awesome. So let's start with free fall motion after a 15-minute short break. Okay, we'll be taking a short break and then we'll be starting free fall motion and we'll return. Okay, cool. We'll be taking a break. Do all these things if you're watching it recorded or live accordingly. If you're watching it recorded, come on. Meanwhile, comment, share the video, like the video, obviously, and subscribe to the channel, guys. Okay, so we'll meet after 15 minutes. Oh, now am I audible? Thank you so much. I just saw the chat. Okay, great. Now I think I should be audible. I think I was muted for some reason. Yep. The mic is unmuted now. Yes, welcome back, Solo Anish, Srishti, Pavitra, Atluru Krishna, Sweetie, Divya, welcome Pratibha, welcome Zubair, hello everyone. Yes. So let's have a look at this particular simulation before we start free fall motion, because this is very interesting and it's very cool, just like your Captain Shreyas, right? So just like your Captain Shreyas, this is pretty cool, and we'll see this cool simulation. So what you need to do over here, let's see. There's a cannon and we'll shoot a ball and see what happens to it. So let's just fire it. Wow. Goes to the top, comes back, goes up, stops, comes down. During this entire motion, velocity changed the direction. Yep, it was going up, stop, and it came down. And velocity was not even constant. Slowed down, stopped, increasing speed now. So it was accelerated. So let's have a look at the acceleration. This is going to be represented by that yellow line. So if you see the acceleration, see, it's always down and it is always constant. What does this tell you? The acceleration due to gravity. Okay, probably I'm just going to turn off the light so that it is seen even more clearly. The acceleration due to gravity is constantly acting downwards. The acceleration due to gravity is constantly acting downwards, and acceleration due to gravity always pulls you down. Correct. Awesome. Okay, what about velocity? Let's have a look at the velocity and see how it goes. Probably you might not be able to see it so nicely. So what I will do is I'll reduce the speed a little bit, maybe 16 or 15. I'll also put it to slow motion and show it to you. Look at this. How that green vector reduces, becomes zero and turns before it starts coming down. It turns before it starts coming down. Isn't it amazing, guys? It keeps changing. And who does this change? It's the acceleration. So if I put both these vectors onto the same diagram, notice how the green vector, which is velocity, reduces. A yellow vector always remains constant before it comes down. If obviously I reduce the speed, it will not go up so much. Earlier it was going till here, now it is only going till here, and then it is coming down. If I again increase the speed to 18 or something, you will see it will go up even further up before it stops. It stays in the air for the longer time and it comes down. Interesting thing to also notice is I have turned off the air resistance, but if I turn on the air resistance, which happens in reality, then it will not go till this height. You will see it will stop well before that, because the air resistance takes away some energy. Instead of going there, it is only going till here. See, with air resistance, it is not able to go till here. It is reaching only till here. So the air resistance has sucked away some amount of its energy. If I remove the air resistance again, it will shoot up really high because air is no longer resisting the motion. Isn't it cool, my dear students? Yes, Lions, did you love the simulation? Yes or no? Quickly let me know in the chat box. And now let's go ahead. Yep. Great. Great. So now let's see all the important pointers. Let's see all the important pointers for our accelerated motion under gravity, which is also called as free fall motion. So free fall motion means motion under gravity. It just means motion under the influence of gravity. Under the influence of gravity. And when you study motion under gravity, we are neglecting air resistance. So when you are studying it, air resistance will be like, hey, listen, don't worry about me, it's okay. All right. So that is what happens. So you ignore this air resistance, even though the air resistance actually is there in reality, because it is going to make our situation complicated. Now, this acceleration due to gravity is always going to act down, just like I showed it to you some time back. It's always going to point downwards, number one. Number two, the value of this acceleration due to gravity can be calculated via formulas or even experimentally. Galileo and so many others, and even today you can do it by dropping objects. It comes out on an average as 9.8 on the surface of Earth. There are small variations at different places, but on an average it is 9.8. But for calculation's sake, instead of 9.8, we'll take the value of small g, is acceleration due to gravity, as 10. So this is that small g which we are talking about. Approximately, we will be taking it as 10 in most cases, unless it is specified as 9.8. When you throw a body up, it decelerates, decelerates, decelerates until it stops and reverses the direction for a brief moment and then again starts to accelerate down. So at that point, the velocity momentarily, for a very small teeny mini instant, chin to minto instant, becomes zero. Also, the upward and the downward motion are symmetric, meaning whatever it does while going up, it does the same thing while going down. Observe this. How much ever time it took to go up, same time it took to come down. With whatever speed it went up, the same speed it will come down. With whatever displacement it went up, same displacement it does while going down. Why is it so? Because the acceleration is same while going up or while coming down. So hence the motion is symmetric in nature. So upward and downward exactly are same. It's just that one is upside down of the other. Also, remember, there is nothing like, gravity is negative or gravity is positive for a given problem. It depends completely on your choice. Meaning, somebody might say, for me, upwards is positive. Somebody else might say, for me, downwards is positive, sir. Now, you tell me, acceleration due to gravity always acts down, right? Acceleration due to gravity always acts down. If Pandu says, for me, upwards is positive, sir. So for Pandu, G value will be negative. Champa says, no, sir, for me, downwards is positive. So for Champa, G will be positive. I have seen many school teachers and many teachers, even for NEET, saying, while going up, G is negative. While coming down, G is positive. Let's all clap for such amazing personalities. Guys, there is nothing like that. That is wrong. And you need to understand why it is wrong. It's not like going up, G is negative. No. While going up, it depends on you. Champa says downwards is positive. So even when the ball is going up, G will be positive. Because for Champa, downwards is positive. What will be negative for Champa is velocity. Because Champa took downwards positive, right? So while going up means velocity will be negative. But for Pandu, who took upwards as positive, Pandu will say velocity is positive, sir, but gravity is down, so G is negative. So depends on the observer, depends on the frame of reference. Exactly, Heroine, correct. Depends completely on the frame of reference. Preferably choose positive direction in the direction of motion. See, this is the statement which is important and many people miss. See, if a ball is going up, I mean, obviously, you will choose upwards as positive for simplicity's sake. But there is no hard and fast rule. You have to take upwards as positive. No. You have to take the motion direction as positive. No, there is no such hard and fast rule. It's preferable. It's a matter of choice. It becomes easy. It becomes easy to understand and draw. That's fine. So that is why they say while a ball is thrown up, G is negative. Actually, you're taken upwards as positive. While coming down, G is positive. You're taken downwards as positive. So nobody mentions that. They fail to mention that. That is the problem. Okay. Okay. Let's see. This is there as a concept action, concept question in Tatva. A stone is thrown up from the surface of the earth. What is the direction of the velocity and acceleration of the stone on its upward motion and downward motion? Let's draw the situation. Velocity like this, then like this, then like this, and then stop. And once it stops, it does exactly the same thing. Motion is symmetric while coming down. This is velocity. And the direction of the velocity is this. So this is your velocity. So this is your velocity. So if I choose upwards as positive, upwards as positive. Firstly, while going up, the velocity will be positive, then obviously velocity is 0, and then velocity is negative. This is how it will look like. But acceleration due to gravity was always down. Here also, here also, here also, here also, here also, here also, here also. G was always down. So acceleration due to gravity, which is G, okay, actually it will be minus G. It will be negative. It will be negative because it was always downwards. And in fact, it is a constant. And what is also special to see is at the topmost point, if you focus your attention, guys, at the topmost point, just when it is turning around, exactly over here, interesting thing to note is that velocity is 0, but acceleration, but acceleration is not 0. In fact, in fact, in fact, the acceleration is still there as minus g. The acceleration is still there as negative g. That's very, very important. A lot of people think, sir, velocity is 0, acceleration is 0. Yo, what are you saying, bro? No, bro. Acceleration is still there. Even if velocity is 0, it is possible that it was just for a moment that it stopped. Got it, everyone? With me on this? Shall we go ahead? Yep. So with Shreyas Sir, with your captain sir, you learn not just how things are done, but you also understand it. See, guys, I have seen a lot of people. I'm telling you, even on many national level channels, teachers just tell you this is this is that, this is this, that's it. And that is why many students, they do not crack NEET examination. Reason is you do not understand it from the basics, from the fundamentals. In fact, if you just see a lecture with just, this is what this is, this is what this is, this is what this is that, that's it, like a pointer, like a procedure, not like a why is this happening like that, then you might probably be like, sir, this is easy, I don't have to use my brain. If this is happening, then I'll use this formula. This is happening, this is formula. When that happens, I don't know what to do, sir, because I just know if this happens, this happens. If that happens, I don't know what to do. So that is why that logic is important. That is why that understanding is important. And sometimes what happens is, the question gets twisted. The same question gets twisted. This is given, this is asked. If that is given, can you find what was given? The reverse of the problem. No, sir, I just know how to solve it like this. I don't know how to go like that. So all these things can be overcome if you learn it the proper way, if you understand how things have to be done. That is very crucial. Cool. So that is what it is. And moving on now to the equations of the vertical motion under gravity. Hello, Chinu. Thank you, Jay. Thank you, Krishna. Thank you, Pratibha Satyashri. Thank you, Conan. Thank you, Divya. Thank you. Thank you so much, Satyashri. Thank you so much. Okay. So now let's see the equations and vertical motion under gravity, all these things. So first of all, let me draw our beautiful ground surface, or this is our horizontal level from which we are going to throw that particle. So it's going to go up till it stops and it comes back right over here. And while it is doing so, you are throwing it with some speed u. When it comes, hits the ground, it will hit the ground also with the same speed u because of symmetry. At the topmost point, the velocity will be 0. So this was your upward journey. This is your downward journey. And during this entire journey, of course, the acceleration due to gravity was always downwards. Now, I want to find many things in this. One of the things that I would love to find out is what is the maximum height till which it goes. So I want to find what is this maximum height till which it goes. In order to do that, I'll do one thing. I'll just consider the upward journey. Consider only the upward journey. Consider only the upward journey. and let's take upwards as positive. I want to find this height, that means displacement. I know the speed, acceleration. So I think the third equation. So V final square minus is equal to U square plus 2 into A into S. If I use this equation, I think we'll be able to figure it out. Hello, Kirtana. Yep. Yes. Okay. Even without solving question in physics, you can get 85. I'm so glad, Gopinath, you said so. But it is actually true also. Many students did that last year with all the tricks that I gave. And if you learn it properly, you can get 170 plus, which again, students have done. One student called me, so I was watching your YouTube classes, I got 170 plus in physics. NEET 2023, this is the story. NEET 2024 also. But again, many students have got good marks because of the inflation part. Anyways, so coming back over here, final velocity is 0 only for the upward journey. That means only consider the journey while going up. That's it. Initial speed u, acceleration negative because it's down, and upwards is considered as positive. Displacement is upwards, that means it is positive. That's it. So bring this on the other side. So 2gh is u square, therefore h is nothing but u square by 2g. So that is your answer. H is u square by 2g. You have to remember this maximum height formula because it will save this time in the examination. It will save your time in the examination. Perfect. Let's go ahead to the next one and let's try to find the total time of flight. See, it started over here at t is equal to 0. It completed its total journey after capital T. This is your time of your flight. How do I do that? Interesting. I can see one thing. In this entire journey, when I come back to the same point, my displacement is 0. Oh, so maybe displacement. S is ut plus half a d square because time is related. So how about using this? S is ut plus half a t square. Let's just simply take upward direction as positive again. Always the sign convention is very important. In your rough work also show that sign convention so that you do not get confused. Exactly. Yep. So now let's go ahead and see, substitute what do we get. In this entire journey, consider for the entire journey, when I'm applying this equation, this displacement, because initial and final locations are same, displacement is 0, u is u, positively up, yes, time is t plus half, g is down, so negative g, time is total time. Perfect. So what do I get? Take that g t square by 2 here, get that ut over here, tt cancels. So gt by 2 is equal to u, therefore t is nothing but 2u divided by g. Perfect. So that is your total time of flight. That is your total time of flight. Also, this tells me that since the motion is symmetric while going up and down, therefore, the time taken to go up, which is also the time taken to come down, will be exactly half of this. It will be u by g. These both should be just the total time, divided by 2. Keep that in mind. Okay. So again, a very, very important, relation that you should remember. Because the motion is symmetric, right? So u by g to go up, u by g to come down. So total time is 2 times of u by g. Remember this. Exactly. Can we use v is u plus at formula? Yes, why not? So say for example, I use that formula also. I will still get the same answer. T is 0 and this is basically total time t. If I use v is u plus at, considering upward direction as positive for the entire journey, what happens? What's the final velocity? It is u, but with downward sign. So that's why negative u. Final velocity is negative u because downwards, right? So upwards is positive. Initial velocity is plus u. Very important. And acceleration is negative g. Time is total journey, so total time. Bring gt on this side. So it will become gt is equal to u plus u. So basically t will be 2 times of u divided by g, which is exactly the same thing what you got over here. It shows multiple kinematic equations will still give you the same answer. It's a matter of choice which one you are comfortable with. But anyways, you're going to remember this formula. This is the procedure. We'll be like, should I, why are you showing all this? Most of my teachers didn't show all this. Forget two methods, they didn't even show one method. Or even if one method, I just by-hearted it. Why are you bothering, sir? Why are you wasting our time showing us these derivations? Remember, this is a procedure to solve other problems. I'm showing you the derivation because when problem comes, every time this formula may not be applicable. So you should know when it is applicable, when it is not, and when it is not, how to apply kinematic equations. That is something which you should be comfortable with. Yeah. How to know when to use the correct kinematic equation? With practice. With practice. That's it. That's all. Okay. There is no other way. You solve many questions. Every model solve 2 to 3 questions. Every single model. Finding maximum height, 2 3 questions. Finding displacement in 9 seconds, 2 3 questions. Dropping a stone from the top, finding the speed, 2 3 questions. Finding the time, 2 3 questions. At this time, at this height, at that time, what height? At this time, this speed. At this time, what speed? 2 3 questions. Solve many questions, guys. There is no other option only. If somebody else has told you, I have a trick, you have to do this, that's it, it will work. I also want to know if you get to know something like that. Okay, there is no other way. The problem is most of us feel that there is always a trick. Most of us feel that the problem is also YouTube and Instagram, because some or the other trick comes somewhere and you're like, I saw one trick, but they get a lot of views. Also, I can also do that, but the problem is those tricks are not applicable every time. Some tricks, I'm not saying in just projectile, every time in some or the other concept, and that is the main issue. And when those tricks are not applicable, you're like, wait, I watched this reel, I saved this reel, I thought this trick is applicable every time. Problem is disclaimer is not mentioned, and we find it hard to accept that sometimes it is just procedural. Sometimes the answer is as simple as completing your homework, completing your DBPs, just doing the regular stuff. That's it. That's a simple trick, simple practice. That is the answer. It's not very complex. It's not something which is hidden from you. It's there in the broad daylight. You just have to practice. Okay. Let's go to the next few questions. Yeah. Also the sign, Gopinath. Thank you, Atluru. Yep. Now, let's have a look at the next set of equations when you drop something. When you drop something, guys. So sometimes, you might be dropping something or you're throwing something from the top. Let's say you throw something like this. It goes like that and falls over here. Or you just drop it. So it just starts accelerating and hits the ground. Or you are deliberately throwing it with some speed. So it increases the speed and hits the ground. So all these kind of questions are there. And all these questions, the simple answer is use kinematic equations. Use kinematic equations, as simple as that, with correct positive, negative convention, sign convention. That's it. That's the basic thing which you have to do in most of the things. So one such special case is motion under gravity wala, and you drop it from a tower. So let's do that. You are dropping something. That means velocity is basically 0. So it slowly begins to accelerate, increase the speed, and it hits the ground over here. Let's say it hits the ground over here and hits the ground with some nice speed v. Okay, and all of this being done, this is This is height h. You drop something, it hits the ground after some time with certain velocity, and I want to find, let's say, how much is this velocity? Okay, I want to find how much is this velocity. How do I do that? Interesting. I know the height. Okay, I know one more thing, gravity. Acceleration due to gravity is downwards. Okay, let me choose upward direction as positive. Let me choose upward direction as our positive direction. So, which equation can we use? Sherlyn, this is the last topic after this problems, and that's it. Okay. V square is u square plus 2as. Oh, why do I want to use upwards positive? It is simple if I take downwards positive, guys, because the motion is downwards. So I'm just changing it. It will be easy. Final velocity v. Initial velocity, I drop something, so 0. Plus 2 into gravity will be now positive because downwards is positive. I am also going down, so displacement is also positively h. So V square is 2gh. So V will be under root of 2gh. That is the final answer. Again, you have to memorize, so don't waste your time in the examination. This is only valid when you drop something. When you drop something, none other than that. Okay? Only when you drop, velocity is 0. If it is not 0, like you're throwing it up or throwing it down deliberately, you have to use kinematic equations because you see this derivation involves u is 0. So if u is not 0, you will not get the formula. What about the time? Can we get the time? After what time does it hit the ground? This was dropped initially, t is equal to 0. Which equation can we use? I think the second equation. Yes, again I take downward direction as positive. Let me use s is ut plus half at square. It is my displacement. I have come down by a height of h. Downwards is positive, h is positive. U 0. Acceleration due to gravity is obviously downwards, so it is positive again. Time is the total time. Perfect. Move this on the other side. So 2h divided by g comes down is t square. So therefore, t will be root of 2h divided by g. So that's your final formula. How much time does it take to fall down? This is your time of fall. This is also done. So all these four formulas you should know, guys. What are those formulas? When you throw it from below, how high will it go? U square by 2g. How much time will it take to go up and come down? 2u by g. U by g to go up, u by g to come down. When you drop something with zero velocity, speed with which it hits is root 2gh. And the time to fall is root of 2h by g. As simple as that. So that was your vertical motion under gravity. So now let's see the questions which are remaining, and yeah, this chapter comes to an end. Agluru NEET PDF is available only. It should be. Just check this out. As you're watching this video, what is NEET PDF? NEET PDF is your one-stop solution for most of your NEET needs. So it's got a very amazing thing. So guys, it's pinned in the chat box also, and it's also there in the description box. Your one solution for NEET 25. Click on this link, and it should open up. Now, what is happening is, why it is opening for me is because I have already logged in. So it might show a pop-up message, email ID or phone number. Create your Vedantu account, okay? Free account. Just create it, only then this will open. Yeah, it's freely available, all these things. Mind maps, revision books, I opened some mind maps, right? So this is for physics. Same way it's there for bio, everything. You have questions, you have previous year papers, PYQs, free mock tests, all of this. This is only available for limited time. It will be taken down from the server. I'm telling you in advance. Later on, you might not see this link. Okay, cool. Chalo. Let's see our next question. What is this? A ball is thrown up from a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. How high will the ball rise? How long will it before it hits the ground? Tell me one thing. Can we open any direct formula now? Oh, sorry. Can we use any direct formula now? Come on. Can we use any direct formula right now in this problem? Let's draw the situation if you're not able to understand first. So how high is the building? 25 meters. So 25 meters is this height. And from this point, you are throwing a ball up with what speed? 20 meters per second. So it goes up and then it will come down over here. Okay, like this. So question is, how high will the ball rise? I think for this part, what you can do is only consider this uh, section of the journey. Just see this. If you just consider this section of the journey, this looks like your normal vertical projectile motion where you are throwing the ball from the ground. Just that instead of the ground being here, now it is here. And for this much part of the journey, I can find the height using u square by 2g formula, and this speed being 20 meters per second. So u being 20, 20 square by 2 into g is usually 10. That is 400 by 20, which is nothing but 20 meters. Perfect. So we got it as 20 meters. Correct? Everyone with me? That is 20 meters from here, from the ground, you can add 25 meters more. That's not the only question. So first part is done. How long will it take before the ball hits the ground? Okay. So when it hits the ground, if it starts over here at t is equal to 0 and completes its journey after some time, in this entire journey, if I take the downward journey or the downward motion as positive, think logically, this is final, this is initial, so the displacement is downwards. The displacement is also downwards. This is initial, this is final. So displacement is positive. And how much is the displacement? It is plus 25. Yep. Don't worry about, sir, it has gone up and down. That is what exactly displacement is. It is just joining a straight line between initial and the final locations. That's how much you have displaced. Use this equation because this equation is only valid for displacement, not for distance. S is plus 25. U is, see, it is upwards, opposite to the sign convention. That's why it's very important. So minus 20t plus half into acceleration is downwards. So plus 10 into t square. Did you understand why the signs are exactly the way I have shown? Did you understand why the signs are the way I have shown? Everyone with me? Okay. So now what you can do? 2 goes with 2 basically uh, goes with 10 5 times. This 5 goes with this 24 times, with this 5 times. So hence our thing which is left is 5 over here. 5t square is over here. So bring that on the other side. So 0 is equal to 5. No, 5 is also not there. In fact, just t square minus 4t, and when I bring it over here, it is minus 5. So it's a quadratic equation. So t minus 5, t plus 1 is 0. This means t is equal to either 5 or it is equal to minus 1. But time can't be negative, right? Time can't be negative. So this is not possible. Negative is not possible. It is not possible only. Negative. The only thing which is acceptable to me is this. This is positive. Hence, the final time which it takes is 5 seconds. That should be the answer. So 5 seconds and 20 meters. Yep, perfect. 20 meters it goes up. We saw that here. And 5 seconds is the total time. Very good. Awesome. So this is why I said clearly, very clearly, whenever you have these kind of questions where it is going up and coming down or just coming down, except for this, you just can use kinematic equations. Even for this you can use, but for this problem, we already derived the equations, whatever are needed. For anything else, use kinematic equations like we did over here. Okay. This question, oh, this is again the same thing, right? 20 meters, 25 meters, the same question. It's just 20 meters from the point where you've thrown. But I think here, from the ground they have asked, the same thing it is, not different. We just solved it. We just solved it, guys. And we figured out from the previous answer that this was 20 meters and this was 25 meters. So the maximum height which it goes is 20 plus 25, which is 45 meters from the ground. The same thing. So 45 is option A. Yes, this is option A. This was asked directly from NCERT. So, NCERT problems, in-text questions, exercise questions become very important. Ball is thrown up with some speed. It passes the same point at 3 and 7 seconds from the start. The maximum height achieved by the ball is. Very nice question this is. This is very, very good question. Okay. Let's understand it. At 3 and at 7 seconds at the same level. We know the entire motion is symmetric. So while going up from here, the time was 3 seconds. While coming down from the same level, the time was 7 seconds. Guys, because time taken to go up and coming down is the same, this entire journey, just this much part, guys, how much will it be? Just this much part. Can you guess how much will be that time? Delta t. It will be 7 minus 3, which is basically 4 seconds. That's the total time. That's the total time from this point to this point. So this includes the time taken to go up plus the time taken to come down plus the time taken to come down. And both of them are equal. So the time taken to go up 2 times is basically 4 seconds. Therefore, the time taken to go up is basically 2 seconds. But from which point? From this point. From this point, I'm just considering this part of the journey, that green part which I have drawn. Okay. But we already know this much part takes 3 seconds. Guys, it's like now saying from here to here, I take 3 seconds. And this is basically from here to here. And from here to here, I take 2 more seconds before I stop and I turn around. So 3 plus 2, how much is this? 3 plus 2, how much is this? This is 5 seconds to go basically up. This is 5 seconds to go up. So that means this is U by G. Therefore, U will be 5G, G is 10, so U is 50 meters per second. How much is the speed? 50 meters per second. Awesome. But that's not the question. Question is find the maximum height. All right. What's the maximum height formula? Let's use it. It is U square by 2G. U is 50. So 50 square by 2 into 10. 50 square is 2500 into 2 into 10. 0 cancels. 250 by 2 is 125 meters. Where is it? Option number 3. That is correct. Perfect. Awesome. So sometimes you have to play around with the equations. You have to break down the problem into part by part. And what a lovely question this was. Did you enjoy this question? Yes or no? Did it not clear so many concepts? Because many people do not know how to start the problem. So that's why always draw. Then mark whatever is given, what is not known over here. Then I understood, oh, wait a minute. I can just forget this part. This looks like a normal upward and downward projectile motion, vertical projectile. So this time will be 7 minus 3, which is 4 seconds. 4 seconds is total time. So just to go up is just 2. If this is 2, this is 3, this is 5. So for this entire upward journey, it has taken 5 seconds. I can find the speed which is there over here. So that U is basically this speed over here. This U is what I have talked about. Once I know this U, I can find the total height using U square by 2G formula. So one leads to the other. One thing leads to the other. What a lovely question. Moving on to the next question, guys, coming up on your screen. Let's keep having fun while solving the questions. A body is thrown up from the ground. It reaches the maximum height of 100 meters in 5 seconds. After what time will it reach the ground from the maximum position? Interesting. Probably we again have to draw the question. Body is thrown from the ground. It reaches a maximum height of 100 meters in 5 seconds. Okay. So it has gone up by 100 meters. Okay. Body is thrown vertically up from the ground in 5 seconds. This is t is equal to 5 seconds. It reached over here. Perfect. After what time it will reach the ground from the maximum height position? Ooh. Again, while coming down, won't it take the same time? Won't the downward journey also take 5 seconds more? That's it. Because symmetric motion, guys, upward and downward. So I think the answer should be just 5 seconds. And yes, it is 5 seconds. How many of you wrote 5 seconds? That's the important thing. Yep. Very good. Excellent. Moving to the next one. A body is thrown up from, acha, this is done. A body falling from rest has some speed after height h. How much distance it has to fall down for its velocity to double? How much distance it has to fall down to double the speed? Interesting. Yep. Let's see. I drop something. And it comes down by height h. And over here, the velocity is v. And we all know v is root of 2gh. We just saw this formula. Now the real question is, same thing, how much should I drop? In fact, I will call this as x, so that our velocity is double. Our velocity is basically double. Wait a minute. 2v will be root of 2g height. Height is basically x. But wait a minute, this v which we are talking about, is this velocity, which is root of 2gh. Oh, okay. So if I put that over here, what happens? I can just square both sides. So this will become 4 into, and this will become 2gh, and this root will go off. So it will become 2g. Oops, I think I wrote h here. This was x, guys. So sorry. This was x, this was x. A lot of things will get cancelled, of course, like this g and this g, this 2 and this 2. So what is that value of x that you are getting? You are getting the value of x as 4 times of h. So answer is 4h. Yep, that is option number B for biology. Very good, Pratibha. Yep. Yes, you have a class, I think, at 9 o'clock. I think Deeksha ma'am is taking that class. Don't worry. We are on the last few problems. Yep. Moving on to the next one. This was asked in NEET 2022. A stone is thrown vertically down with some speed from the top. It reaches the ground with 60. The height of the building is how much? You're not dropping it. You are deliberately throwing it. That is very, very important. With what speed are you deliberately throwing? 40 meters per second. And what happens because of that? It falls down by some height, which we exactly do not know. And this is our ground level. And it hits the ground with a much larger speed, of course. What speed does it hit? 60 meters per second. And during this journey, I know g is down. And I can also take downwards as positive for simplicity. Question is, find this height. I can't use any known formulas apart from kinematics because I'm not dropping it. Which equation do I use? Initial speed, final speed, displacement. Time is not given. Third equation, right? Makes sense? So let's use the third equation. V square is u square plus 2as, taking downwards as positive. So downward final velocity is 60. Initial velocity downward is 40. Acceleration is plus 10. Displacement is h. So this will be 3600 minus, sorry, is equal to, this will be 1600 plus 20 into h. You can definitely cancel this 0, and this 0. Okay, perfect. And oops. And we will get basically h is equal, or rather 2h is equal to 360 minus 160 whole thing divided 9. That's it. So I can take this 2 below so that I can divide it. What is the answer that I will get? 360 minus 160 is 200. So h will be 100 meters. Just check this out. 100 is D option. Yes, it is. Perfect. We got it. Very good. Excellent. So guys, this is how motion in 1D questions are. It's not that difficult. Awesome. Awesome. Oh, that's it. That was the last question. And we have completed this class. We have done 1D motion completely with a good level of practice. Obviously, there will be more problem solving classes which you will have to attend, and you have to do a lot of self-study on your own. You can't be like, oh, I just watched this class and I'm going to be, yeah, a master. Obviously, a master needs to practice to become a master. So thank you so much, and do drop in the comments of how you enjoyed this class. And next class will be on motion in 2D, which is motion in projectile, right? That is something which we'll be doing. Okay. So God bless you all. Take care and have a great time. And keep attending the classes with full enthusiasm. Do not give up, no matter what, because your target is NEET 2025, 720 out of 720. All the lions quickly roar in the comment section. Bye bye, Captain Shreyas signing off. Hasta luego.